Hello, everybody. Welcome to another Royal Room Rumble with yours truly, Mark Reid. Now, I know I haven't been heavy on the Room Rumbles lately, and I do know some people love them, some people don't love them so much. Sometimes they're rumbly, sometimes they're not so rumbly. But over the last couple of days, there's been a lot of rooms come up that I've luckily been awake for because I'm in Australia. But yeah, a few of them came up, and I've got a series of three for you. So this is actually going to be a three-parter. It's all regarding evolution. The first part was on Standing for Truth's show, where Mr. Hovend came on and was answering questions, so I jumped on that, and everybody got to ask questions. He left when it came to me, so as soon as it came to be my turn, he didn't want to take questions anymore, and he was out of there like the massive Hovend hustler that he is. So there's Hovend just doing the dodge at the start. I'm not going to click. I suppose it is a bit clickbaity to have them there, but I put him in a chicken suit so you know he's running away. Um, and it sort of got down between me and Donnie, which was weird. And of course, there was Sam there who was being a complete ass in the background as per usual. So thumbnail is appropriate. Um, so it was for the it was actually straight after a debate that my good friend Dok Dino did. Not Doctor Dino, the fake Doctor Ken Hovind, but Dok Dino, who's not a real doctor either, but he is a has a geology degree and is does paleontology. So he's great. Did a fantastic debate. I will link that below, as well as all the original links as I do. And he did a fantastic job. So he got to speak a bit. I must admit I hijacked it into genetics. So started talking about that and going back and forth with Donnie, with Sam interrupting to talk about whatever bugbear got up Sam's nose this time. Redefine Living doesn't have much to say really, but it kind of was. It was interesting. I had a good conversation, and I think that Doc Dino did fantastic. There's a few more usual suspects in there. Bubbles jumps in to say nothing coherent whatsoever. A few other people jumped in, and yeah, I think it was interesting. I think the question that I wanted to reiterate wasn't actually asked by me. It was asked by another panel member. See if you can pick it up. It was basically to Kent Hovind. Brilliant question, not mine. Brilliant question though. It was if the birds are sort of up on the top of the a fossil record because they were flying, as he said, when the flood happened, and so they think last. Then why aren't pterodactyls at the top, and pteranodons and other flying dinosaurs, flyosaurs essentially? Why aren't they at the top? And he just ignored the answer, just ignored the question, gave an answer to some other question. I don't know what he was answering. And then I wanted to bring that up again, and he just, yeah, he did a dodge. I'm sorry, he did a dodge. So yeah, that's another running away from Kent Hovind, and you'll get to see a discussion where yeah, the usual mayhem ensures between the minions down at Hovind's little minions down at Dinosaur Adventureland YouTube channel, or Standing for Truth. So I hope you enjoy. It was great, and again, I'll have another couple of parts to it. I'm so proud of Dok Dino. He did a fantastic job. Again, I highly recommend watching that debate between him and Kent Hovind. You know what Hovind's going to say, but Dok Dino, he really did a great job, and I can't recommend him higher enough. Of course, I'm going to put his link in there. Of course, I'm going to put his link in there. What are you talking about? Of course, his link will be in there. Lots of love, and let's get ready to rumble.
If a monkey in Africa started, learning how to type on a typewriter, slowly turning into a human, how's that going to spread around the world? They're claiming this happened. I would like to see some real science to back this up. But I am dead tired. I got to get to bed. So 9 o'clock. I promised you till 9. Now, I'll take these other guys on individually anytime.
He's going to
do
run
this every day.
Yeah, no, I can't even take a question from me.
Mark, I don't want you to do that because we agreed 2 hours for Kent. We've just hit the 2-hour mark.
Yeah.
So Kent is being gracious with his time.
for Kent. Yeah.
And Kent, I appreciate it. We are going to be, it sounds like we're doing this again next week with AJ as the front runner. So
doing the Hoven hustle. Yeah, there we go. Go on, Kent. Off you go.
All you guys come
Mark,
to
can you behave and stop the over talking?
Well, I came in here to ask questions. I can ask one
Mark.
question.
He just challenged you to a debate. So for you to just slap him as he leaves, like he said he was going to do, that's
okay.
I mean, that's pretty weak.
Well, I think it's pretty weak to sort of bring up somebody's personal information
Mark,
as well,
Mark,
Sam.
Hammer down, Mark. This isn't the Mark show. He said he was going to be here for 2 hours. He challenged you to a debate. Let him know when you're ready. And
well, sorry, I came in here thinking we were going to be able to ask
questions.
Hold
on, Mark. For the third time.
Shut his mic off. Shut the mic off, please.
Yeah,
okay, shut it off.
Juvenile. This is ridiculous.
No, thank you. I promised you 2 hours. I gave you 2 hours. I'll do this every day of the week. But 2 hours is about all I can go. I got people coming to visit from all over the world here. I'd like you to come down to Dinosaur Adventureland. Even you atheists come down. We can have the debate right here live on our channel, Genesis Baptist Church, or on YouTube at Kent Hovind Official. I mean, on Rumble and all the other ones. So my contention is nobody's ever seen any animal produce a different kind of animal. Nobody's ever seen that. You can imagine it. You can put them in layers and imagine that. It doesn't prove. That's not science. You cannot prove these layers are different ages. All the layers formed at the same time. Every molecule on the planet's the same age. I stick by my guns. I believe the Bible is scientifically accurate. God made everything in 6 days. That's the only way it works. I'm not demanding that be taught in science class, but that is my claim that it is. You're demanding that we teach all the animals came from an amoeba in science class. That's not science. You have a religion, and you will not admit it. So make another debate tomorrow. Donnie, schedule it tomorrow if you want. I can postpone my program. All right, thank you.
Okay, Kent, thank you for your time. For the audience sake and the panel, we did this with Kent about 13 days ago. And then 2 weeks before that, we did one. 2 weeks before that, we did another one. So we do endless open mics, and we always get a lot of people joining. And so that's awesome. There's a lot of people willing to engage this topic, skeptics and non-skeptics. Unfortunately, that means not everybody is going to get the amount of time with Kent that they might want. But again, we will do one probably in about 8 days. It sounds like AJ and Kent will. Good. I see you nodding your head, AJ. So that'll be fun. And then we'll do the same thing. We'll have an open mic, and it is the summer. And so we're trying to make this the summer of debates and open mics. And so we'll try and do these a little bit more frequently and give everybody the opportunity to engage. So, okay, I guess it's kind of more of a free for all. Now there are a lot of points on the table. Sounds like we've been talking about beneficial mutations. Paul has brought up a couple of good points, I think, in terms of the distribution of mutations and fitness in general. And so why don't we allow one of the skeptics to make a point or say something that they'd like to, and then we'll just kind of go from there.
Yeah, and let me just say I got to go to bed as well. I'm not too much of a night owl, unfortunately, so don't have much longer. If anybody wanted to say anything to me specifically, let's do that, and then I'll have to sign out.
Cool.
Yeah, I think it's a little bit unfair for Kent to put words in my mouth and say that I made all of these claims, these straw man arguments, and then leave before I get to respond to him about it. I never claimed that beneficial mutations cause one organism to take over the population, and that you need a male and female that have the same mutation to breed with each other for the child to get that mutation. Mutations can be inherited.
I think what he was trying to get at.
I'm not done talking. So just look at Mendel's Peapod graphs. We know this, and it's a ridiculous argument that Kent keeps making. He's made for years this idea that one organism, one animal gets a beneficial mutation, and that causes it to take over the population, and then he'll compare that to Hitler somehow. He always does that, and then you need a male and female, and they have to find each other and be interested. I never said anything like that, you know. So
well, let me explain
just wanted to say that.
why it's erroneous. Okay, so instead of just saying, hey, it's wrong, let me explain why it's wrong. And that's because if a beneficial mutation does actually come up, it will mate with another animal that doesn't have the mutation. Some of the children's have that beneficial mutation, some don't. Now, if it is such a benefit, the ones with the mutation will get selected. So they will be a larger group within the population, which will then spread out and mate with other animals, and that process will be repeated until such a time as that mutation spreads throughout the population enough so it becomes fixed in the population. You don't need 2 animals. You only need one with a beneficial mutation.
Hold on, but you have to
Yeah,
have to
just
understand,
don't interrupt me,
like,
Sam. Don't interrupt me. Come on.
When mommy and daddy have
Yeah.
a baby,
Yes.
that baby has the mutation, right?
Or not.
It has to breed.
Sometimes.
So you have to have.
Yeah.
Well, that's how it gets
You guys
passed
have heard of
on.
obnoxious?
Do any of you
The
guys know
child,
what biological
the
noise
generation
is?
has the mutation,
Mhm.
and it has to reproduce.
Yes.
So that's going to involve something else.
What do you mean?
So yes,
something
it does
else?
need to find something, and it does have to reproduce
Yes,
in
but-
order for that
But
mutation to even have a chance.
Yes, but Sam, you've
to
misunderstood.
get continued on.
The claim was that
So
both.
that's what he's saying.
No.
You got to have
No.
two. You got to have
Sam.
one that has the. Mark,
You've
why are you
misunderstood.
overtalking? Mark, you don't need to overtalk.
Okay,
We
we'll
can
finish
behave
what you've
here.
got to say then.
Like, we can behave, right? Let's just
Well,
behave.
I can.
When you have a mutation that takes place in a generation, it requires more than that. It has to find a mate, and it has to reproduce. That's a bare minimum. So yes, you need one that has the mutation, but then you have to have another one for it to breed with.
So can I explain?
Hang
real
on.
quick
Well, let
something
me
in
respond to that. Come on. Okay. So yes, but Kent's claim was that you need 2 organisms with the same mutation. That isn't true. You don't need 2 with the same mutation to get the ball rolling. Okay, and then it spreads throughout the population. So this whole thing is, yeah, it needs to find a mate. What's hard about that in a population?
Survival is what's
So I
hard.
could ask
Survival is the hard part.
Sure.
There's something called biological noise. I'm just trying to, like I said, I gotta leave quickly here, but we're kind of all talking past each other and not hitting what's important here. Biological noise, and AJ or Doc, Mark, do any of you guys know what biological noise is in population genetics?
Are you talking about genetic drift? Or are you talking about sort of genes that aren't expressed?
No, it's not really either one of those. Now, drift might be potentially considered part of the concept of noise, but basically, if you think of a mutation as a signal, and the effect of that mutation on fitness or survivability, if you consider the effect of the mutation as the strength of your signal, okay, then noise would be other factors in play with respect to reproduction that have nothing to do with that mutation. So noise is just stuff that is interfering with your signal, preventing your signal from being heard. Now, that's all kind of an abstract way of saying that in order for a mutation to have enough impact on an organism to affect it in any meaningful way with respect to reproduction, that mutation has to have a fairly large impact on the organism.
Mhm.
It's not going to be a small impact, because if it's a small impact, it is going to be overshadowed by far too much noise. And when I say noise, anything that's not related to that mutation is noise. A tsunami hitting, a famine hitting, and just any tiny little thing that happens. Maybe they're very fit, but just they get unlucky and they step on a rock that slips in the wrong way and they die. This happens all the time.
Mhm.
So noise is very significant. And it is true that any single mutation is more likely to get eliminated by noise than it is to be passed on, even if it is beneficial. So these
No.
are really huge hurdles for evolution. even a beneficial mutation is still more likely to be lost than conserved. It simply is, because there's just too much death happening in the natural world.
I think that
I
we
will
need to-
disagree with that statement, but
Yeah.
that said, you said you have to go to bed. I would be happy to discuss this further if you'd like some other time. My email's on my YouTube channel.
I just think it
Nice
should
meeting
be
you. Paul, I
established
think your
that-
name was. Please have a good night.
Wait,
I think
hold on,
I think
Paul,
Doc
before-
is actually sending me to bed.
Yeah.
Yeah,
that's
I
some-
do. Well, I
without,
just
without
Paul?
dessert.
Doc, he didn't
Well,
say.
no, I acknowledge your
Doc,
time.
he didn't
It's
say he's
fine.
going to bed right this moment. So I think a couple
Oh,
of the
yeah.
panelists.
He was
I'm
trying to get
talking-
out here, and we just
guys,
kept pulling him
I'm
back.
talking. So I think a couple of the panelists wanted to engage a couple of Paul's points. If I'm not mistaken, I think Mark, you were next up, and then we'll kind of go from there.
Yeah, and I do have to go to bed, so but yeah, if you want to say anything real quick before I go ahead now.
Yeah, cellular noise seems to be related to gene expression and the influence of external events on gene expression. The thing is that regardless of the noise, any beneficial mutation that will provide, like if you've got an animal that has a beneficial mutation that can eat something other than what they can eat, right? Just say they have a beneficial mutation where they can eat berries instead, then that will counteract the famine that occurs, for instance. So in fact, those beneficial mutations can be selected for by exactly what you've described. Just say there is a tsunami and a flood. Something with a mutation that allows it to float or swim better will actually be selected under your own criteria, Paul. So I'm really sorry, but you're really wrong about that. The cellular noise that we're talking about is whether it's expressed or whether it's not expressed. And if it's expressed, and that does help with the sort of, I think it's sort of genetic drift that you're talking about, which is sort of random events occurring, then that beneficial trait will be selected for. So it doesn't actually matter. Because
Okay,
the flood
that's-
will kill all the ones without the beneficial mutation to float, and the ones that can float, they will pass it on. It works perfectly.
But that's an interesting hypothetical that you've come up with here, but
so are yours.
it's not really it's not it has nothing to do with the point I was trying to make.
Yes, it does.
Yes, it does.
Obviously, if
No,
a
it
flood
doesn't.
happens and then you've got some weird hypothetical mutation that causes you to float when you couldn't float before, I don't know what that would look like, but yeah, maybe in that situation. What I'm talking about is most people that get hit by a tsunami are going to die regardless of their genetic fitness. And even if they are slightly more fit than their peers, they are still going to die if they get hit by a tsunami.
Sure.
Let's say that you had a good mutation that causes you to process your food more efficiently, so you have greater endurance or something like that.
Mhm.
Still, a rock can fall on you and kill you. Still, you could get taken unawares by a tiger. Still, you could just happen to not get lucky and not find a mate,
Sure.
for reasons that have nothing to do with you.
Yeah.
Yes.
Most people
R-
die, and most animals die for reasons that have nothing to do with their fitness.
And how many
And
animal
that is
species
Sorry.
are extinct?
Sorry, if I may, Paul. I agree. A lot of creatures die due to things that are outside of a mutation's ability to affect. But their sets of mutations can bias them to be better in different situations or different environments. Those are the
Yes.
mutations that have big effects on a population.
And
Yeah, but if you look at the distribution of effects for so what we're trying to bank on here is big effects. That was your phrase, big effects. But we know, and nobody that has ever studied mutations would ever try to claim that mutations with big effects are even remotely equally distributed between negative and positive. All mutations are weighted toward the negative heavily, but if you single it out only to those which are of big effects, then you're talking pretty much 100% negative.
Okay, Paul, what do you
so-
think I'm meaning by a big effect?
Well, if you're talking about anything that's relevant, then what you're talking about is a mutation whose fitness impact is great enough to outweigh the effects of biological noise. So it's a strong enough signal that the noise is the noise does not drown out that signal.
Okay, Paul, if a camel has a mutation that makes it so it doesn't need as much water and it lives in a desert, do you think that mutation will give it a better odds at surviving to make offspring?
A better odds, maybe, if all other things are equal, but that camel can still get shot by a gun.
Yeah, of course.
Paul, I'm agreeing with you on that. I'm telling you that it needs it to be better.
Yeah,
like
just because something is slightly better at something does not protect it from the world around
Correct.
it. Okay?
And how many animals have
played
gone
D&D,
extinct over the years?
Sorry.
Tons of them have gone
Sorry, Mark.
extinct.
Have you ever played D&D, Paul?
Well, just let me make one point. Just let me make one point.
Hold on, you guys. We're gonna do one at a time, and so Doc, go ahead and finish your thought to Paul, and then Jackson, you were next, and then Mark, you can go. But I want to walk through this too, so I want to jump in. So, yeah, go ahead.
So, Paul, have you ever played D&D?
No.
Okay. So in D&D, a lot of actions are decided by a random roll of the dice. It can give you any number from 1 to 20. Sometimes when you make a roll, you get to add a number to that roll, say a +1 or a +2. I'm saying that camel gets to roll the dice, and if it rolls above a 10, it will be able to give birth to children in the future. All I'm saying is that the mutation gives it a +1, so it's slightly more likely to give birth to children.
Yeah, I totally
it can still
understand
be randomly,
that's
but
that's
it
trivially
has a better
easy to understand. I understand that concept. The problem is that it's just not biologically realistic to
It might get
apply
eaten by
that.
a dragon though and die.
I mean, yeah. I mean,
hold on.
life is not Dungeons and Dragons, obviously. Yes, this mathematical concept that you have in your head works as a mathematical
Well, it's a
concept.
simplification. It's an example. I'm trying to make it simple. I can't account for all variables.
The problem is that it's so much of an oversimplification that it becomes misleading. Because in reality, there are so many factors that affect our reproduction, and our genetic fitness is probably the least of those factors most of the time.
Okay. Sorry, I think you're just being intentionally obtuse. I'm done with this
Hold on,
conversation.
Doc, Paul's not saying anything that's necessarily inconsistent with what you're saying. You can have, even if we grant you that +1, it doesn't mean that a tiger isn't going to come along and eat that thing before it can reproduce.
That's what I'm saying. That's exactly right.
That's what the noise is. It's just random occurrence. If you're going to compare it to a game, it would be more like chutes and ladders. Like, yeah, you might climb up, but then the next step, you're going to slide all the way back down to the beginning in an analogy like that. But so Jackson, I know you wanted to say something, but I kind of wanted to jump in too, which is really relevant. So go ahead, Jackson, and then I'd like to make another point. And then Mark, I know you're itching.
And Paul, I know that you wanted to get to bed soon, so don't feel obligated to have to stay around. Whenever you want to go to bed,
can I chime in with something?
Yeah, go ahead.
I can.
All right. Basically, I just want to say a couple things.
Well, my main question for Dr. Dino is just, I'm asking Dr. Dino, do you know about TP53, the gene? It's responsible for DNA repair. So if the DNA can't be repaired, when P53 is dysfunctional, this protein prevents the cell from dividing and signals it to go apoptotic by stopping cells with mutated or damaged DNA from dividing. P53 helps prevent the development of tumors. Because P53 is essential for regulating DNA repair and cell division, it has been nicknamed the guardian of the genome. So if you had a dysfunctional P53, Dr. Dino, do you think that you would just get an equal distribution of mutations that would be beneficial and unbeneficial? Or do you think that people would be so riddled with cancer that they'd be like walking? When you see people with dysfunctional P53, they generally develop tumors so rapidly that it's almost, you wouldn't even recognize that, like, they're overgrown.
Okay. So my answer to that would be, I can't say whether most of the mutations would be negative or beneficial, but if P53 does what you say, then it would cause just a runaway train of mutations.
It does.
That would
That's why
probably eventually wind up in the death of the organism. Just because
That's
there's no
exactly what
mechanism to
happens.
prevent it.
That's exactly what happens when you have dysfunctional P53. You
Yes.
have runaway cancer rates and death of the organism.
And that's
But
removed
if
And-
what you were
gene pool.
saying was true and random mutations were as likely to be beneficial as they were harmful, why would you see runaway cancer? You might just see like 50-50 chance you become more evolved, 50-50 chance you become cancer ridden.
And
Have you
removed
thought
from
about
the
this,
gene
or are
pool.
you just, by the way, are you just
Okay,
winging it,
so-
or are you just
So
before you
sunflower?
end,
Sunflower,
have you,
let
have
him,
you
let
looked
him
into
finish.
it?
Sunflower, let him answer.
Okay, okay.
You know, you can't just.
Yeah, sorry. Just I agree with you that if mutations are unregulated, they can lead to disaster. That's why genes like P53 are
Do
important.
they more
They
often lead to
they
disaster?
limit the number of mutations that happen.
Doc, do they more
acknowledge that.
often lead to disaster than not?
I don't know if I'd say disaster, but
Oh, like being ridden with
sure.
tumors.
Let's say sure.
Your
Where are you
entire
going to go with
body
this?
is riddled with tumors, overgrown everywhere.
Then you die and you don't have children. And then someone
Yes.
who has a functional P53
That's
does.
exactly what happens when you have a dysfunctional P53. Are you aware of that or not?
I will say yes, based on what I know of it. And
So then it sounds like mutations aren't like neutral. It sounds like they are catastrophic.
okay, it depends on the mutation. It depends on what the mutation is in.
Generally speaking, the reason we need the gene P53 is because of how harmful mutations are. If we didn't have this gene, we'd be walking cancer overgrowths, every single one of us.
I agree. Your point being,
My point being, you can't. Mutations are overwhelmingly harmful.
Yeah,
We've
they're much more
conceded that
likely to do
point.
damage than
No.
to help. That's what the point Sunflower's making here is that the fact
We
that when you get runaway mutations, it's obvious that it's a negative effect, but that's really uncontroversial. Even the population genetics experts in the
That's
field
right. But Dr.
recognize.
Dino was trying to dispute this and saying, well, no, actually, they're
Well, yeah, but I'm not sure he's ever actually studied population genetics, and he's certainly not
I
read
have,
any of the
thank you.
experts in the
What?
But wait,
field.
but Dr.
Rude.
Dino,
It's
you
just a
did
rude thing to say.
dispute. Dr. Dino, you did dispute. I can pull this up in the chat here. You do not. You are. I'm looking at your messages saying no. It's not more often harmful than it is beneficial.
Okay, Sunflower, let me explain my position.
But
My
you
position.
did say that,
Sorry,
right?
Sunflower.
Okay,
My
go ahead.
position is that the majority of mutations are neutral, and whether they're beneficial or harmful is very dependent on the
The
situation.
environment.
That's
Now,
wrong.
a mutation like you described in P53 would be very detrimental. I agree, and the organism would likely not reproduce to pass on that
Dino,
mutation.
wait, I have to
But
interrupt you.
not all mutations are like that.
Dino,
That is my position.
P53 is correcting the other errors in the genome that happen naturally. That's what you're missing here. P53 is called the protector of the genome because it repairs the random mutations that are already occurring. Okay,
Sunflower?
P53 is correcting these mutations.
Yes, but
Sunflower.
if there is
They're
a
happening in your
mutation,
Sunflower,
body.
you were saying 1 + 1 = 2. I'm saying I agree 1 + 1 = 2. And you're saying no, 1 + 1 = 2. I
No,
agree
that's not-
with you,
no,
Sunflower.
I have to stand for
let
this
me
here
try to
because you just
unpack
said-
it.
No, because you
Sunflower
just-
is saying that there
Wait,
are
wait.
mutations that are
Redefine.
occurring, and
Let me explain this. Let me explain this. No, Doc, you just tried to say no. When P53 is dysfunctional, that's when things get crazy. The point is, P53 is repairing the errors that are. Have you ever heard that like there's cells in your body that would turn into cancer every day if it weren't for your own, basically repair mechanisms? That's what P53 is doing. So it's yes, in a sense, yes, a dysfunctional P53 will lead to you becoming cancerous only because there's other mutations that are rapidly firing off in your body that are now no longer being repaired. So you have to realize these mutations that are always happening, these errors, they're being corrected for by built-in repair mechanisms in your genome.
Yes,
Okay.
Sunflower, I agree with
Those-
you. Can we please move on?
Well, but okay, but you have to accept that if these mutations are causing cancer, like
Look,
in
Sunflower,
like
what we're
alarming
saying,
rates.
accepts it.
what we're
He accepts
saying
it.
is the outcome is that the mutations are largely neutral. Okay, you're sort of saying, hey, before this repair mechanism kicks in, the mutations are largely detrimental because if you turn off this, they're all detrimental. But we're saying that what we see in organisms is that the mutations, at the end of the day, they're largely neutral. Largely.
That's
I don't
true.
think
I agree
that's
with you on that.
Okay,
hold on,
That's
we all
because
agree.
hold on, Sunflower, hold on. I've been patiently waiting.
Okay,
So
but
to say
I agree with you, Mark. Go ahead.
that they're largely neutral, that's not accurate. You can say that they're slightly harmful, but they are a shuffling of information. Now we went down this rabbit hole of this magical beneficial mutation, which fine, we can grant you that. But the overall problem that we seem to be dodging is that you're going to, in order to have that one mutation get fixed, and you need it to get fixed, along with that mutation, you're going to have at least 100 other mutations that are going to get fixed along with it by default. So for each, even if we were to grant you one seemingly beneficial mutation per generation, you still have to deal with those 99 that natural selection is not going to remove, because if it does remove them, then there goes your beneficial mutation.
Okay,
So you have a huge problem
can I address
of
that?
mutation accumulation that's taking place. And if you want to, and every time you deal with that and say, well, we have this mechanism that's going to remove these harmful mutations, well, there goes your beneficial mutation.
Yep, I can deal with that. Sure. So what generally happens, and Dok Deinos was right that mutation is a variable amount that happens. Sanford was wrong. Sorry, Sanford was wrong when he said that it was only at one rate. That is incorrect. That does that happen at different rates. Now, what happens is that though that beneficial mutation we pass to a number of offspring, as will a random amount of those detrimental mutations, because don't forget the child genome is going to be a random amalgamation of the parents, as well as its own mutations as well, if they do, and sort of point mutations may occur. So what happens is that over a large population, what will happen is the ones with the beneficial mutation will be selected for because they will be the ones more likely to survive, while the ones with the beneficial mutation and detrimental mutations will probably be removed from that gene pool. What's happening is that even slightly detrimental mutations, they might not be removed from the gene pool. It's once it hits a sort of catastrophic mutational load that organism is then removed, and we see this all the time. We see that hey, it might have a slight mutation that can still survive, but if they pile up, eventually it will reach a point where that organism and all of its possible descendants will be removed from the gene pool, and that's how it removes those mutations. But it will probably select for the organism with the beneficial mutation and none of the detrimental ones, or the one with the beneficial mutation and just the neutral ones. Because if it does have a detrimental mutation, it will be less likely to survive. If you're talking about an organism that has a mutation that turns off P53, for instance, that instantly that mutation is gone from the gene pool because it's instantly removed. That organism is not going to survive to have children.
Okay, I'm going to address that. So I appreciate those points, Mark. I'm going to get in on this now. This is a good topic, a lot of fun. So that is essentially what is referred to as the mutation count mechanism, where over time enough nearly neutral or low impact mutations will build up in a population that are essentially invisible to selection, but eventually they build up to the point where there's enough genetic sickness in that population that selection can see and remove that organism from the equation. Firstly, I want to point out, I've got it up on screen, it is a well understood and well established principle that the vast majority of mutations are deleterious. This is right from the conventional literature. They also acknowledge that most of these mutations are nearly or effectively neutral. So what that means is they are not big enough in terms of their deleterious effects for selection to see, but they are slightly deleterious. They go on unnoticed. A good illustration would be in the wild, where you have, let's say, a zebra is born with one leg that's too short. That's a big enough mutation for Mother Nature to see. And so that zebra is probably going to be dinner for the lion, while the other zebras might be able to get away. So that mutation's big enough for selection to see. So yes, selection can see the big mutations. Selection can see your rare beneficial mutations. The Lenski experiment has documented that your beneficial mutations are roughly 1 in a million. They're very rare. When they do occur, they're typically reductive. Even though the so-called lactase mutation is due to a mutation in a pre-existing regulatory system. We can get into that if you'd like to later. And so phenotypically, yes, there's a lot of positive effects with these beneficial mutations. But when you look under the hood, when you look at the genotype, mostly we're looking at reductive. We're looking at mutations that are overall functionally compromising to organisms. So the point I want to make to Mark, yes, strong proponents of genetic entropy, whether it's myself or Dr. John Sanford, Chris Root, people who have done a lot of work on this, Dr. Rob Carter, we recognize the fact that there are variations in fitness. Fitness variation exists. But the problem is every single person on this planet, let's take humans, 7 to 8 billion people on the planet. Every single person on the planet is passing on roughly 100 new mutations per person per generation. Most of those being nearly neutral. Selection can't see them, which means they're subject to genetic drift. Okay, so let's, for sake of argument, apply heavy selection to your worst mutant on the planet. Remember, everybody's multiply mutant. Everybody has inherited about 100 mutations from their parents. Your parents inherited about 100 from your grandparents. So everybody on the planet is multiply mutant. So if you were to apply heavy selection and remove 50% of the worst mutants on the planet, let's say 4 billion people, well, is this going to solve the genetic degeneration problem? No, because you're still left with 4 billion people that are more mutant than the generation before it. And so all you can ever do is slow down the genetic degeneration process. You're never going to solve it, because the whole point is that every generation is a little bit worse off or a little bit more mutant than the previous generation. So yes, what Mark is saying, once the mutation load in a population gets so large, selection may be able to see it, but by that point, it's extinction. That entire population, let's say in the case of humans, is essentially removed. So it's never going to solve the problem. Go ahead, and whoever would like to respond.
I'd like to respond. Donnie, may I?
Sure, Doc.
Yeah.
Mark, could I really quick? Right. So I took a look at this paper because it's on screen, so I figured I might look at it. Maybe just a difference of interpretation, but what they seem to be saying is that the majority of mutations they have found are objectively deleterious, but most of them don't affect the organism in a given environment. They are negative depending on context. Also, what you're talking about of the population just being overloaded by negative mutations, if you could provide me some sources for that, I'd be interested in taking a look at them. But as far as I know, that's not the common consensus for why species go extinct, or at least not the major cause.
What does objectively deleterious mean? Can you just explain that really quick?
So, like, they're worse at processing a certain food, but they get so much of it in a lab environment, it doesn't really matter. Stuff like that.
Right.
Okay, let's allow Mark to now respond
But
uninterrupted.
that's not an impact? Wait.
Yeah, it's not, because
actually, Sunflower, what we'll do, anybody who wants to get on this specific discussion, we'll go around the room. Okay, so I went, Doc just went, now we'll go Mark, Reid. I assume Sam's going to want to go. We can have, whoever. I'm screen shared, so I can't really see everybody who'd want to get involved. But let's go. We'll keep this orderly. So Mark, go ahead. Feel free to respond to whatever you'd like. And then other panelists, make sure you're taking down whether it's mental notes or written notes, and we'll make sure everybody gets the opportunity to respond. Mark, go ahead.
Yeah, and in the conclusions of this paper, it also talks about displaced gamma. where a shifted gamma distribution has the effect of truncating the distribution of mutations below a lower limit. So it's basically saying that once the mutational load gets to a certain point, those mutations and the genetic codes are removed from the gene pool because they're so deleterious at that point. They pile up, and that's what all of the papers say on sort of these deleterious mutations. I talked to a geneticist, and he corrected me on that medicine hasn't sort of stopped genetic selection from happening. What it's done is it's broadened our tolerance for deleterious mutations. Now, you're saying there's no way to solve it, but that simply is not true. If we have medicine that can change, like we can use a CRISPR to change genetics, then we can solve these genetic problems. Because once you change the genetic code, then it isn't passed on to the offspring anymore. So Donnie, I'm really sorry, but you're 100% wrong. Like, there is a way to solve it. We might not have the technology yet, but you're sort of saying, hey, there's no way to do it, which I don't think you can make that argument, because you don't know what genetic sort of technology we'll have in the future. And anybody, no, Sunflower, I'm not waiting. Please let me talk.
Okay.
And plus,
Sunflower, you're going to get your chance. Okay, we're going uninterrupted response.
And plus, like all of the papers that I've read, and what the consensus among geneticists is that once those deleterious mutations pile up, they get selected against. And we have seen this time and time again in labs. Like, for instance, the genetic entropy that said sort of Sanford and Donnie and all you guys say should be happening doesn't happen in Drosophila. It doesn't happen in the labs when we've done experiments over multiple generations. There's this genetic decay. Those populations should be wiped out if you are correct. And they're not. They're still going. So it shows that in a practical sense, when you get it in the lab and you actually do these things, it's completely wrong. Completely wrong.
Okay, thank you, Mark. We'll hand it to Sunflower. You've been patient. And then Sam, I know you want to get involved too. So yeah. Sunflower, go ahead. We'll start with you.
Yeah. Sorry to interrupt. I should have been more respectful of uninterrupted stuff. My fault on that. But my main question would be, when you talk to that geneticist, I mean, there's a thing to be said about, like, you know, we have like modern medicine in terms of like diabetes treatment, and maybe other, like we have treatments for other genetic diseases that would have been maybe the end of a genome previously, but that's totally different from CRISPR. I mean, like, was this geneticist saying that like modern medicine, were they equating the fact that genetic mutations are piling up to like CRISPR? Because that's a whole different thing than just modern medicine letting ill people reproduce. You know, I mean,
he didn't really he didn't say that, but what I'm saying is he said that my misunderstanding that modern medicine sort of caused detrimental mutation buildup was erroneous. All it does is increase our tolerance for those mutations, is how he described it.
But we haven't implemented CRISPR yet, as far as I know. Correct. To like literally
guys, I don't want to cross-examine each other.
I said,
guys, I'm jumping in. I don't want to cross-examine each other just yet. Uninterrupted responses, and then eventually we'll open it up again for more of a free-for-all, ask each other questions. So, Sunflower, try not to ask a question.
Yeah.
Okay. Sorry.
Unless it's like rhetorical or something.
Fair enough.
Want Mark to answer later.
Okay. I won't do a response to that question, but I'll make a brief point that was kind of tangential to all this, but it'll be very brief. Don't worry, and no one has to touch on it if they don't want. I really do think that the scientific method really came into existence and still exists as a means to an end. As in, if you have a overarching moral dogma or purpose or framework in which you can apply the scientific method, it's extremely useful. But once you let people say that, no, this scientific method is now going to replace, whatever purpose or meaning you felt you had as a human, Now you can just look into the science, and it'll be like peering into a crystal ball, and you'll end up with a reason to keep existing and persisting in life. I think that's really a bastardization of science. I think it exists as a tool, not as a end in it of itself. And I think it's dangerous when people start using the scientific method and essentially worshiping it as something that can provide meaning in and of itself. I think it provides a way to be skeptical of other people, to tease out the truth. It will never give you a reason to live and a reason to be excited about life in the future and a reason to be hopeful. And that's why I think it's in the modern era, it's very much being misapplied, and it's not being, it's a tool that's been, sort of co-opted, and I think it's like a dangerous weapon in a lot of cases. You wouldn't trust a random like, you have to get a license for a gun, but any person on the street can start, wielding science to what they think will be whatever, to whatever end they might get to. It could be
Sunflower.
That's it.
I
It's all.
appreciate that.
Yeah,
Okay,
yeah.
I appreciate those points. Let's for now do our best to keep it on the genetic entropy topic. Thank you, Sunflower, for those points. We should probably go, one evolutionist, one creationist, one evolutionist. So, Doc, if there's any points you wanted to make, and then I think we should throw it back to Sam. It doesn't necessarily have to go that way because, I'd like to respond to a couple things from Mark. But to be fair, Doc, let's hand it to you. Feel free to respond to anything you'd like to. Then we'll throw it over to Sam.
Sure, thanks. Just I find genetics interesting, but I honestly, it's not my wheelhouse. So I'm good to just wait until we have some more paleontology or geology questions.
We'll definitely get on to the human paleoanthropology question because there's some points I'd like to make on that. So Sam, over to you, brother.
Yeah. So when you guys, if you go back and you listen, both Doc and Mark acknowledged outright genetic entropy. So Doc says that, yeah, well, they are accumulating, but they're not really affected in the wild. Right. That's the point. There's nothing that's going to remove them. And so when I talked to Mark previously about how do you separate the good ones from the bad ones, he kind of gave an example, but he keeps referring to these things as though that you can remove one thing at a time. It's not. They're whole sets. If you have one beneficial mutation get fixed, then along with that, you've had multiple other ones getting fixed. But notice when Mark was talking about it, on one hand, he fully acknowledged that mutation accumulation is a problem. And he did that when he said, well, we can fix it with CRISPR. Well, wait a minute. Is there a problem that can be fixed, or is there not a problem? If there isn't a problem, then why do you need CRISPR? And if there is a problem, then you've just acknowledged it. And that's the point. The medical journals are full of paper. I've been trying to find this link, and I will, hopefully, when it's my turn again, I'll share my screen. But I mean, there's literally thousands and thousands of genetically inheritable diseases currently in the human population that are not going to be removed by natural selection. Now, the geneticists that Mark talked to about medicine, look, to clear up any confusion, we've heard that before. What the geneticist was trying to say, and you can correct me if I'm wrong, is that medicine has prevented natural selection from working the way that it would if we didn't have medicine. Meaning that the medicines are keeping people alive and they are reproducing these mutations into the population, which they previously would not been able to do if there was not medicine. And that's all true, but that totally misses the point. And it acknowledges the point. The point is that there is a problem and there is no solution. And we can put people on medicine to try to help it. But these mutations are accumulating. And if you play it back and you listen to their previous responses, on one hand, they're acknowledging, and I think Doc missed it. But Mark, I'm not saying this deflationary, but he's talking on both sides. On one hand, he's fully acknowledging it, but then on the other hand, he's trying to pretend that somehow it's not a problem. Which is it? And then lastly, when you say that Sanford is wrong, is that an accusation that you're able to defend, or is that just something that you're saying to defend your position, but it's vacuous?
Yeah, okay, so you
That's
brought up
it.
a whole lot there, Sam. So, that's a bit of a gish
Not
gallop. I'll
really.
go through all of it. So genetic entropy, no, we don't believe in genetic entropy. That's just some sort of end point to the whole thing. The whole point is that we're saying that these detrimental mutations come to a critical amount and then they're removed from the population. That is not the idea of genetic entropy. That is the build up until, some sort of catastrophic event, which we're not saying at all. So no, we don't believe in genetic entropy as far as you say. This whole idea of sets, what you've got to understand is not all mutations are passed to your offspring, that different offspring will have different sets of both beneficial and detrimental mutations. Because you're thinking of it as, well, a detrimental mutation exists, it's passed to all offspring. That isn't necessarily true. Just because someone has sort of a mutation that is sort of maybe diabetes or something, right? So they're susceptible to diabetes. That's not necessarily passed to all of their children because there's two parents involved, not one. We're not cloning them. They're not automatically passed down. So you will have the offspring with different sets of detrimental, neutral, and beneficial mutations. And the ones that have the more beneficial ones and the more neutral ones rather than detrimental are more likely to produce offspring and survive, therefore creating different sets that include more of the beneficial, more of the neutral mutations rather than the detrimental. So you seem to be missing that. I didn't say we could change it with CRISPR now. I said at some point in the future. And that was only because Donnie said, hey, there's no solution. And I said, hey, in the future, there might be a solution with CRISPR to take these mutations out. Sort of what I said with the tolerance is higher. I'm not talking both sides. I'm saying, yes, detrimental mutations do build up, but when they hit a critical point, they're removed. They don't have children. So why we need to use CRISPR if they're removed anyway? Well, I would imagine that someone, say with diabetes, for instance, would be vastly happier having that removed from their genome than actually having it there. So it's not just, hey, we've got to do it because, people have to survive. It's also to improve quality of life and things like that. So I'm not pretending Stanford is wrong. I've got, there are papers where he has used a constant for mutational change. And like I have papers that say that is completely and utterly incorrect. In fact, the person he used their formula to calculate that mutational change rate says that his calculations were wrong. And that was a really, really famous sort of dig at Stanford's work from the person that came up with that formula. So no, I'm not just sort of making it up. No. But what I would like to know is why wouldn't something with, if these mutational loads build up, why wouldn't an organism with a critical amount of these detrimental mutations, like sunflower described, why wouldn't that be removed from the gene pool? Why would it still continue and have offspring?
All right. Yeah, I'm going to address that. And I'm actually shocked that you still do not understand the argument at all. And so I'm going to break it down very simply so the audience can grasp it, even though I think your worldview is preventing you from grasping the argument. Each generation is accumulating. Hold on. Each generation is accumulating 100, and that's a very conservative number. 100 mutations. Okay, so your parents, 100 mutations from their parents. You picked up an additional 100. So you can't go back in time to that more perfect genome. So moving forward into the future, each generation that survives, reproduces, picks up 100 new mutations. So every child that is born has 100 additional mutations, and that is 100 more in this long line. Now, on an evolutionary timeline, that's ridiculous. You've got millions or billions of harmful mutations. You'd be dead a million times over. On a biblical timeline, we don't have as many mutations. But this is the part that, Mark, you don't get. So when you say, well, once they accumulate to the point, then the organism is going to die. Yes, that's the problem. But the problem is, Mark, if you are born, you have 100 additional mutations. So everyone who survives has 100 additional mutations. And if they reproduce, and that child lives, then they are going to have even 100 more. So there is no going back and dealing with it.
Let me jump in real quick, Mark. I know you're making
sure.
notes.
I do want to
everything.
address that,
And
though.
Yeah, of course. I think I've been patient because I haven't had a chance to respond to the points from like 10 minutes ago. So I'll go, and then we'll hand it back to Mark. And I think this is a good format. So Mark brought up essentially truncation selection. Yes, if you read through these papers, if you read through Kondrashov and his work on why are we not extinct or dead 100 times over, I hear some feedback. So I just want to make sure, check who it is. I think it might be you, Abraham. So I'm just going to mute you real quick. Okay. So you'll notice here from Michael Lynch, world famous population geneticist, he points out that the average newborn contains roughly 100 de novo mutations. So the evolutionary community and all serious population geneticists, they do recognize the fact that the mutation rate is quite high. Now, there is a range from high to really high. So you can have somewhere between 80 new mutations per person per generation up to sometimes 200 new mutations per person per generation. Notice here from Kimura, effectively neutral, but in fact, very slightly deleterious mutants. So he's pointing out that your neutral mutations, your effectively neutral, are basically just very slightly deleterious mutations. They're not big enough, like that example I gave earlier, where you get a zebra that's born with one leg too short. That's a big mutation. He's going to be breakfast, lunch, or dinner for the lion. He's probably not going to survive very long. Okay, a single point mutation can kill somebody. And so there are mutations that selection can see for sure. But the majority of these, roughly 100 new mutations per person per generation, they are effectively neutral or slightly deleterious. Here, Kitely points out it seems unlikely that any mutation is truly neutral in the sense that it has no effect on fitness. All mutations must have some effect, even if that effect is vanishingly small. So those population geneticists in the conventional literature, they have looked to truncation selection, which Mark talked about, so that's good. They've looked to synergistic epistasis. They've looked to various models of mutation count mechanism, which is basically what we've been talking about here, where you've got a population that is accumulating many thousands of nearly neutral deleterious mutations, eventually enough build up in that population that selection can now see the damage, basically. But again, I've pointed out earlier that your damage is population-wide. Every single human being on the planet today has accumulated 100 to 200 new mutations per person per generation. There's a lot of attacks on Dr. John Sanford and his credibility. I would challenge anybody to simply look at his resume, see all of the technical papers he has written, see all the work that he's put out. He's invented the gene gun. He was able to retire at a very young age and basically do full-time research on this because of his excellent work in the field. And he recently spoke at the NIH, National Institute for Health, by no means a young earth creationist organization. And he spoke on human genetic degeneration. And so Doc earlier asked for the evidence of genetic degeneration in humans. Well, that's exactly what he spoke at through the NIH, because there is a concern, especially with working scientists at the NIH, that autism's on the rise, cancers, autoimmune diseases, mutation-related diseases, the environment plays a factor, epigenetics. And so this is recognized. And so they're looking to solutions. CRISPR, you know, with all the many thousands of deleterious mutations pouring into the genome and basically eroding nucleotide sites, you're going to need some really sophisticated CRISPR technology to fix many thousands of nucleotide sites that have been hit with mutations at the same time, because the load is growing and there's really not much of a trade-off. We see what happens with a trade-off with Lenski's experiment. We see shrinking functional genome sizes. And so the last thing I want to say is I appreciate Mark bringing up truncation selection, mutation count mechanism, which some have referred to it as, but these have been looked at. They've been analyzed. This is Dr. John Sanford at the NIH, and he pointed out the various solutions that have been proposed, synergistic epistasis being one, truncation selection. They've been analyzed using sophisticated numerical analyses where they take into account fitness variation, they take into account natural selection, mutations, beneficial mutations, and the result is always the same. Genetic degeneration is inevitable. It hasn't been addressed. And so I'll yield there. Go ahead.
Okay.
Donnie, I would like to move on to a new topic soon,
Can
if
I just
possible.
can
But
I just
real
address
quick,
what's been said before we do?
well,
Because
yeah, I
let's
just
throw
have
it
a
to
quick
Mark to be
question
fair.
for him.
Oh, if you if you had a quick question,
Yeah.
and then we'll throw it to
Yeah.
Mark to take as much time
Sorry,
as he needs.
there was
Yeah,
a
and then
butt
Donnie,
there.
really quick, don't lose your thought, both of you guys. We haven't had who is it? CR say a word. And Mars Hill, I feel like I owe you an apology. You've been waiting so patiently, and you haven't really kind of got to jump in if you want. But after Dino and Mark goes, maybe you guys want to just say hi really quick.
this is a pretty specialized subject, I got to say. Like,
Right.
I don't
Yeah,
blame
well, they
anybody
can just say hi
for not.
But go ahead. I think
All
Don.
right. So
Don or
yeah.
Go ahead.
Okay, really quick, Donnie. On the topic of, say, cancer as an example, do you think there are any other possibilities for why we're seeing more cases of cancer other than genetic degeneration? Could there be other causes?
Great question. Absolutely. Dr. John Sanford addresses that in his lecture at the NIH. I highly recommend checking it out. I've got it uploaded on my channel. It's got, I don't know, 10, 12,000 views. Definitely check it out. And so he goes over the fact that cancer rates, they're skyrocketing 1 in 3. And a lot of it has to do with mutations. A lot of it has the mutation accumulation, basically relaxed selection as well on humans, and environment. We've got a lot in the environment with the foods, radiation, chemicals, carcinogens. And so there's a lot at play. And so there's environment related entropy as well, for sure.
Okay, thank you. I just wanted to make the point that there is more than one cause for what we are seeing.
It's a combination, many factors.
It's a combination, and there's a lot of arguing within the scientific community, because there always is, about what the bigger causes are. So some might agree with you with the genetic degeneration. Depending on how you define it, that could be happening. But there's other causes too. That's all. Mark, your go.
Okay, so just first on what Sam said, like the 100 mutations, like what you'll notice is, and maybe you saw it on that paper, it says on average there is 100. And also what sort of Sam and Donnie aren't telling you is that it's split into coding and non-coding regions, where the mutation might not actually do anything because that genome is not actually expressed in the organism. So the whole idea that it has to lead to this degeneration, it doesn't happen in the labs, and the whole point is that, Sam's sort of saying, oh, it's 100 and then they get 100 and they get no, that's not how it works. Some of the children will have more, some will have less, some will have very, very few detrimental mutations, or even no detrimental mutations, because the vast majority are neutral. And yes, Donnie's correct when he says, hey, nothing is completely neutral. Yes, it's all very spectrum driven. Some things are nearly so far to neutral it's almost absolutely nothing. Some are neutral because the environment doesn't affect it. Put them in a different environment and it may do. So yes, but most of them are neutral. So the whole idea that they have to get detrimental mutations is just reading 100 and sort of saying, well, each one gets 100 is very misleading. And I think that has to be pointed out. And I also want to point out that Stanford, and I'm not going to, he's done really good work. The gene gun was genius. He's done fantastic work, but that he can't get genetic entropy published. And there's a reason why. It's because the consensus of geneticists don't agree with him. And he has a problem with the way that he's calculating genetic mutation rates. And that is in a fixed linear fashion at a certain constant, and it is just not constant. It is affected by all kinds of things that occurs. Even diet and what environment an organism is in can affect mutation rates. How much sun they're exposed. There's a multitude of things that can affect mutation rates. But if Samford was correct in that certain generations of mutations, and we can measure them in Dropsphilia, which is fruit flies, they have a very, very short lifespan. If he was correct, those colonies would be wiped out, and they are still going to this day. Unfortunately, genetic entropy is not correct, because when we've tested it in the lab, it has been falsified. That is the end of that. And unless Stanford can come out with a paper that gets peer reviewed by the people doing work in these labs with organisms with short lifespans that show genetics to be the way that he says it is, I don't know what to tell you. I can't, he just doesn't really have anything to say. This truncating that we're talking about, it does definitely occur. And, I'm glad that Donnie sort of acknowledges it occurs, but it still means that these build-up of sort of detrimental mutations will be removed from the population. And the whole idea that just because it's a large number, 100, it doesn't say whether it's in coding or non-coding reasons. So even though that mutation might happen, it may not actually be a region that is expressed at all. So it may not have anything to do with it. Epigenetics may mean that it never comes into play, that, yeah, maybe it's detrimental, but it never is actually comes into play at all. So it is not.
May I make a request?
Sure.
Sorry. Just I appreciate you helping, Mark, but just maybe we should try to keep responses to 30 seconds or shorter.
Well, I mean, I'm trying to
just
go through
across
everything
the
that
board.
was gone
I know there's a lot,
all
but
right, well then, yeah.
Sorry,
well,
just it's hard to respond to every point.
I do.
Doc, if you wanted to, okay, you know what, Mark, I appreciate that. Let's throw it to Sam, and let's try and, me and Doc at the same time. We can time if you want, and let's try and limit it now to, let's say, minute responses.
Sure.
As we move slowly towards, I think this has been great. We could probably talk about this all day.
Well, I do acknowledge that Doc's field isn't genetic, so maybe we should shift to his, what he wanted, because it was his debate. I do acknowledge that.
Okay, Sam, let me start. I'll take a minute, and then Sam, you take a minute. Then we'll throw it back to Mark. I know he'll have some points to make, and then Doc will slowly start shifting to some of the points you made in the debate on human evolution. And so let me start my timer. I'll go a minute, which means I probably won't be able to address everything, but I will address as much as I can. So here's at least one paper. There's been many in terms of Mendel's accountant, the sophisticated program that basically looks at mutation distribution, looks at selection, beneficial mutations, truncation selection, and determines if mutation accumulation is resolved, if it can be resolved. So here's one paper, and you look at an old virus, patterns of mutation accumulation. So basically, this is in the secular literature, so you can look at it here. And Rob Carter and John Sanford published, basically assuming that mutation accumulation does result in genetic sickness. They looked at the H1N1, and what they discovered, that due to mutation accumulation and randomization in the genome, basically of this virus, we had a virus that was red hot in terms of being a pandemic, and it went to a whimper and to an extinction event in something like 90 years due to mutation accumulation. The last thing I want to point out is the fact that they've looked in the lab, Lenski's experiment, for example, these E. coli bacteria, we have generations after generations of E. coli. And what they've discovered is, due to mutation accumulation, they have actually shrunk in functional genome sizes. Many pre-existing systems have been destroyed. They've lost a lot of genes for short-term adaptive purposes, but it's actually long-term degeneration. This is well understood in bacteria. It's called reductive evolution, where bacteria will adapt to different environments, but they'll do it by basically losing systems, breaking down pre-existing genes, but overall it results in genetic degeneration. So yeah, we have observed it in the lab, but the concept of genetic entropy was written with long-lived mammals in mind, elephants, humans, and that's where we see these high mutation rates. We see generation times of 20 to 30 years, rather than with bacteria, it's every 15 minutes. And so populations can recover quicker in bacteria. So I'll wrap it up there.
Donnie, brother, can you share my screen?
Sure.
So what I'm going to do, I'm going to take you guys to the most relevant laboratory that we have. And so this here is from medlineplus.gov/genetic/condition. And this is the National Library of Medicine at the NIH. And there are literally thousands. So here you can see they're all alphabetized. And so as I scroll down, I think it's better if we can just visually see like what Mark is saying. This is what he's denying. And so earlier in the stream, we stated, Donnie showed very clearly that genetic decay is very well established. Talked about how Dr. John Sanford spoke at the NIH. I'm still on A, by the way. But Mark says he's been refuted, but it's just been a vacuous statement. And then he says, well, he has to provide papers to prove him wrong. But that's not how it works, Mark. The one making the claim, they have the burden of proof. And so just saying that somebody doesn't like his numbers, that's hardly a refute at all. So here you go. On an evolutionary timeline, on any timeline you want to say, look, we'll go to another random one. Here's like the G's. And we can just continue to scroll through all of these. Now, this makes sense on a biblical timeline. And again, Mark, I feel like every time you respond, you're not comprehending that it's each new generation picks up 100 new mutations. That's 100 more. They don't just disappear. The only way that those things go away is if the organism dies. But all of the other organisms on Earth, they still have all of those accumulated mutations. And lastly, I want to say, it would be better for you, if you want us to take you seriously, to exercise a little bit more terminological exactitude. Because on one hand, you're saying that they're neutral, but you just acknowledge that they're not actually neutral. Then stop calling them neutral. They're not neutral. Don't call them neutral. They're either neutral or they're not. You've already acknowledged that they're not. Stop calling them neutral. Okay? And so, yeah, that's it. Like, I'll put the link in the chat. You can click on any one of these things. It'll open it up and give you specifically an analysis of what it is. Here is what I'm showing. And there's thousands of them. Mark, where's natural selection? Where's the hero?
Yeah, so I'd like to respond to that if I could, because I think that's a bit inflammatory to sort of say that what I said was vacuous and I had no idea and that exactitude. They're called neutral because they have no effect on the success or detriment of the organism's propagation.
I just showed you that.
That's generally why we call them neutral.
Okay.
So this whole idea of the 100 mutations they last in the environment, I think that you're misunderstanding what these mutations are. Like, they're not the same mutations, and they're not sort of, it's not like every single animal gets exactly the same mutations kind of thing. I'm not sure what you're thinking, but they hang around in the environment. No, they don't. You came, the organism dies. Yes, the organism dies. And a lot of these things that you're pointing to, they basically can be managed by modern medicine. So as I said earlier, I'm not sure if my exactitude actually sort of passed you by, but we have a higher tolerance for diseases that ordinarily would have removed organisms from the gene pool in the past. So basically you're pointing to this,
right?
Excuse me. Basically you're pointing to this and
accumulate?
Yeah, basically you're pointing to this and
okay,
basically
they're accumulating.
Yeah, if I could talk, could I please talk?
All right.
Could I talk?
Okay. You're just contradicting yourself. I'm just pointing it out. Go ahead. Which is it?
Okay.
They're accumulating or they're not? We have medicine or we don't. Like, which is it? You're talking out of both sides of your face. You don't even realize it.
Okay, so
You're contradicting yourself every
Sam,
statement
I
you
think
make.
you're just not understanding what he's saying.
No, I showed. I understand.
yeah,
Donnie's giving you papers. I just showed you.
yeah, so you're
Like, we understand it. Like,
So you're pointing
one of us
to a
doesn't.
large amount of diseases that we can now tolerate because of a greater medicine. And those
That
aren't
accumulated, right?
necessarily like diabetes, as I pointed out with a specific example. They're not necessarily passed down to any offspring because they're sometimes in the non-coding regions, they're sometimes not expressed, sometimes they mutate further. There's a whole bunch of things that happens that doesn't necessarily mean that they're passed on. A lot of the times they are, sure. But once the mutational load becomes so detrimental, as you said, the organism dies. Where's my hero natural selection? It's not my hero because we've got medicine to try and increase the tolerance range of what, like, because in the past, someone with diabetes just would have died, but they don't anymore. But we can use medicine to increase that tolerance. It doesn't mean that genetic entropy is going on.
I'm going to respond real quick, Sam.
I'm shocked.
But Mark, in all due respect, you're still not getting it. It's
I'm
the
shocked.
nearly neutral mutations. It's the nearly neutral mutations that are the problem, not the big mutations that kill somebody, not the big mutation in the wild that results in a zebra being born with 3 legs instead of 4, and therefore it's the first to die. No, it's about those nearly neutral mutations that accumulate population-wide. So you keep saying that eventually they'll accumulate to the point where Mother Nature can see the damage. Yeah, the damage is population-wide. So what you get is extinction. That's not going to help the case for you. Every single human being on the planet is multiply mutant. And so what type of selection can you present us with today, Mark, that can actually remove these nearly neutral mutations as they're accumulating before it results in population-wide genetic sickness? Go ahead.
Yeah, so when it reaches a certain critical point, that person will no longer be able to interbreed or survive.
What do you mean that person? Every person has a critical load.
I just
So
gave you
is
a
it
list.
selection going to remove every person at the
I
same
gave
time?
you a
But
list
don't
of
forget-
thousands of genetically inheritable diseases. Thousands of them. It's like you don't even look at it. Like,
Well,
this
Sam,
is
let me just
ridiculous,
cross-examine
Mark.
him real
diseases
quick.
This
kill
is
people,
insane.
Sam?
This is insane.
The diseases
Mark,
kill
this
people,
is
It is,
insane.
Mark.
This is
The
crazy.
diseases kill people, Sam?
Did you not just see what I showed you?
Well, it's a question. Do
This is
diseases kill
ridiculous.
people, Sam? Do they kill people?
Yeah, but that doesn't mean that kills them before they reproduce.
Sometimes it does, right?
Those are inheritable. Inheritable.
Sometimes it does. And
Do
when,
inheritable diseases get passed on, Mark?
sure, and
Mark, do
sometimes
inheritable diseases get passed on?
sure, and sometimes
Do
they
those
don't.
thousands of
Could I
inheritable
respond?
diseases get passed on?
Sometimes they don't.
Just yes
Sometimes
or no.
they do. Yes,
Those
they will
lists
do.
that I just put in chat and showed
However,
you.
when there is comorbidities,
This is
when
crazy.
multiple detrimental mutations build up, usually they will not get to interbreed before they die, and they will remove that specific line from the gene code, and you still haven't addressed why these populations of fruit flies are not having this happen to them. They get the same mutation load.
Well,
Sure.
you know what?
Yeah,
it probably
their
is happening in
reproduction's
fruit.
different,
Let me
Mark.
talk. It probably is happening in fruit flies. I haven't specifically looked at that one, but I've looked in bacteria. Lenski's long-term evolutionary experiment, that's the longest running macro evolutionary experiment to date. And he's documented the fact that, firstly, there's a new paper that came out in 2021 where a lot of these beneficial mutations that were observed, they're actually now being lost. We see that his bacterial species are shrinking in functional genome sizes, but I don't want to get too far off the point. The point is, it's the accumulation of your low impact, your nearly neutral mutation. So it's not necessarily about the diseases. It's not necessarily about the disease that manifests, that prevents reproduction. No, it's the ones that go on unnoticed. And these are only subject to genetic drift. And so if they're subject to genetic drift, what happens? They spread throughout the population. So Mark, I agree with you. Eventually, the damage is going to be so catastrophic that the entire population is now experiencing universal genetic sickness. So is selection going to remove every single person from the equation? Is that your solution?
No, it's not causing sickness, because if you realize that what you said was nearly neutral is ones that would have a detriment in a certain environment, but you're not in that environment. Generally, humans have changed the environment. So those ones that, if we were out in the wild and had, say, a temperature tolerance issue, we don't have that problem anymore. We've removed that problem. So these kinds of neutral mutations that, you could categorize them as detrimental. And Dok made that point, that it's only detrimental in certain environments. They are no longer the detriments that are going to take us out of the gene pool. And that's what increasing tolerance means. We no longer have the problem that if you have low blood pressure, you're going to not be able to hunt or something like that. So these have absolutely been, our tolerance for them is so much higher and so much better that, even if they build up in the population, it's not a problem. And, it's not guaranteed that they will be passed down, because if you get somebody with that mutation breed with somebody without the mutation, it's not guaranteed that that's going to be passed along.
Let me respond real quick. So again, the nearly neutral mutations, I wouldn't necessarily call them detrimental. I'd call a mutation that kills somebody before they can reproduce, or a mutation in the zygote that basically doesn't result in the birth of that being. Or, again, the example of the zebra in the wild that's born with one leg too short, where it doesn't last very long. It doesn't even survive a year or two, because the lion is going to choose that zebra for dinner. And so whether it's in the wild, whether it's in humans, it's not about your detrimental mutations, your mutations that are big enough for selection to see, and therefore there's no reproduction. It's not about your rare beneficial mutations that may or may not be on the genotype reductive. It's about that accumulating load due to the low impact mutations that population geneticists refer to. Recognize there's an issue. That's the whole point of invoking truncation selection, synergistic epistasis, mutation count mechanism. So the point is, when a population reaches a point where their genetic load is so high that selection can see it, it's either extinction or a certain part of the population doesn't reproduce and is removed from the equation. But what that means is every other individual is still mutant. And so it only ever slows down the problem. But what I want to point out here before you respond is you can find paper after paper from Dr. John Sanford and other researchers on this. Some are published in the conventional peer-reviewed literature, others in creationist journals. There's a good mix for you to look at. But here's just some that you can go through. And in these papers, they look at synergistic epistasis. They look at truncation selection. They look at various models of mutation count mechanism. This paper is the one I was pointing to earlier. So if you click it, you can go read it on the H1N1. This was published in the peer-reviewed literature. And it's always the same outcome. Genetic degeneration is inevitable. Yes, there are circumstances where it can be slowed, but never have we seen an example where it can be completely stopped. Go ahead.
Okay. Well, the whole idea is you're using mutation as if it's always bad, like we're all mutants. And yes, that's essentially true. Everything's been a mutant since the dawn of time, essentially. Everything's always mutating. It doesn't necessarily mean everything's headed for a catastrophic state. And this is what the Lenski labs, this is what the Drosophila, this is what all the experiments carry out. Now, you're talking about a virus, which is a bit of a different thing than animals. I haven't looked into that. I certainly will look into it and see if there's any sort of genetic entropy they're sort of saying there, or whether the virus is succumbing to an inability to propagate itself. Because a quick skim, and I must admit this was just a skim, it sort of suggested that it moved away from its host populations and didn't go there, which, tons and tons of extinct creatures have showed us that, extinctions do happen. And just because you're saying, hey, that would mean extinction for humans if this is happening, or if that's happening, maybe it would. It doesn't disprove evolution. There's been 99% of all species have gone extinct. So what does that show? I mean, I don't get your point here really, that evolution isn't true because genetics can't make it true. I don't really understand what you're trying to get at.
Well, basically, the
Mark,
argument,
wait,
I'll
wait.
say this, the argument can be boiled down to the fact that if mutation accumulation essentially puts shelf lives on genomes today moving forward, Mark, then species won't be able to persist for millions of years into the future. Therefore, going into the past, species cannot persist of millions of years into the past.
Yeah, no.
And so it puts shelf lives on genomes today and shelf lives on genomes in the past.
Yeah, Stanford's done a lot of good work, but that sort of constant mutation rate, I mean, everybody knows it's not constant. Mendel's accountant,
he would agree it's not constant. Well, Mark, you keep saying that he says
Mendel's
mutation rates are constant.
Mendel's accountant does use a constant mutation rate.
No, you can do variation in it. You can do a variation in
but
mutation
when you're
rates
applying it to populations, you have to apply the same rate, right?
You can do a mutation rate of 1.
Yes.
And it's still too much for species. 1 mutation per generations.
Yeah.
So for sake of argument, you can run a simulation of 1 mutation.
Yeah, I don't think that's
because
true.
No, but what is true? Because mutation accumulation and genetic entropy, Mark, it's about every generation being worse off than the previous generation. So even if the mutation rate was 10 per generation, that's still more than the previous.
Does Mendel's accountant take into account the beneficial mutations?
Yes, you can set parameters, and it's been done where you have super beneficial mutations, or you have, rather than 1 in a million, you could have more frequent beneficial mutations. And
yeah, I really
all you're going to get.
I really think in order to believe Sanford, I think he should get something peer reviewed as, his model of genetic entropy. I think that's
he has.
Okay, can you cite that for me?
Yeah,
please?
that's just
Mendel's accountant is peer reviewed.
That's just your bias.
Well, that's a model.
That's a fallacy of an unargued philosophical bias. That's all you're doing. You have no reason to dismiss his work. Donnie, can you share my screen one more time?
Really quick, can Mars please go? Mars has to go soon, and he's been very patient. He's been here for like an hour.
Something really quick. I mean, I have articles, Mark. Humans are getting dumber. The human IQ is on a decline. We've got articles that most mutations are harmful. I think I've beat that one up. This one here, I think you might be interested because it's in Australia. We've got humans are losing fertility. Autism is on the rise. Gene loss and broken genes in humans is on the rise. But this one is cancer, and this is in Australia. Look at the title of that. This isn't some creationist site, by the way.
Look,
it talks about the rate of childhood cancer in Australia is increased by 1.2% per year between 2005 and 2015.
Redefine, you got to remember.
And is in it. Hold on, we're going one at a time, and it's expected to go further, 7% over the next 20 years. So, I mean, these are all the results on your. Here's the question that you asked. On your model, Mark, this mechanism that creates beneficial mutations, also, even if we grant those, it also creates an accumulation of deleterious mutations. Now, I've shown you thousands of examples, independent examples. You said I didn't do that. That list that I put in chat from the NIH, there is thousands. I think there's 6,000 or 7,000 independent single examples of a genetic inheritable disease that you can click on any single one of those, and that's going to be one independent line.
Redefine. Remember the way they are. They are defining.
Bubbles, let me finish. Let me finish my thought. So, just really quick, all I'm saying is, I have now given you thousands of independent lines, and you've not given us any beneficial mutation. You keep saying they exist, but we're the ones that are providing the literature and the sources and the references, and you're just You're literally hand waving it away, pretending like we're not even sharing the stuff, and then going
I'll
on
tell
and
you what,
talking
read
without
it.
addressing anything.
You
This
gotta
is
you gotta
so
let the
bizarre,
people know
Mark.
why
This
he's
is
doing
so
that.
bizarre.
Okay.
You gotta let the people know why he's doing that. His
Go ahead.
definition of fitness, if all the retards in the world start reproducing, that is still fitness by his definition. So it will still be
Godzilla, or I mean,
Yeah, I think
Bubblegum.
that's-
Come on,
that's-
come on, man.
yeah.
So you have to point that out.
You've been here for 30 seconds and you made an unnecessary comment. Just keep it sophisticated, like we've been doing.
What's a better
for
word
3.5
for
hours.
the mentally disabled? If all the mentally disabled,
I'll agree that.
start reproducing.
Wait, hold on.
Okay,
I don't
well,
think
I would like
we don't
to
need
respond to
do
what Sam
ad
said. Could you
homs.
throw it out?
Yeah, please.
Yeah,
That'd be
so if
fantastic.
you want
Mark,
beneficial,
please deal with it. Don't
sure.
just hand
If you
wave it
want
away.
beneficial mutations, there's HIV resistance, which I brought up to Donnie before in the case of people having HIV mutating that retrovirus into a beneficial function. I've got lactose intolerance, which Dok Dino brought up. Lactose tolerance, rather than intolerance, and what is it? Trichromatic vision is a beneficial mutation. It certainly can help people, or women rather, because it's women specific. Excuse me, bubblegum. It certainly does help women in recognizing color and fashion industry and things like that. So that can be a beneficial mutation as well and assist in their reproductive success. So that is something that is also a beneficial mutation. So there are definitely a few out there. I think I brought up the case of some people in a car accident I can't remember the state, it was in the US. They actually found to have a genetic marker which had made them have heavier bones, more density. They were sort of better off when in accidents or crushes or things like that, but unfortunately they had trouble swimming because they were actually denser. So there's all these examples of beneficial mutations. Now your whole thing about hang on, I got to address what Sam has said, okay, everything that he said, because I want to get through everything. The whole point about you bringing up children with cancer, children die of cancer. That selects children that survive. So thank you for bringing up a perfect example of how detrimental mutations are removed from the population before breeding age by bringing up deadly leukemia. Well done.
No, Mark, it was the argument wasn't that children don't die from cancer. It was that the rate of children in the population is increasing. I have another article from I like the medical journals because that just really flies right in the face of evolution with literally, again, not to be redundant, thousands of examples. So you gave me a small handful. One of those with the lactose, that's already been addressed as being a deleterious, sickle cell trait. That's another one. That's a disease that has a beneficial effect, but it's not something that you would want. But I granted you them. Here's the thing, Mark, for like the free thinker, right? The one who really wants to freely think about this. And I wish that's you, Mark. Like I hope that's you. But I realize it might not be, right? But anyone else who's listening, if evolution is true, there should be millions of examples of beneficial mutations because that is the mechanism.
Sam, let me address a couple of these real quick, if you don't mind.
Wait, can I go? I got here.
I'm going to go first because I've got my notes here. I don't want to forget. There's some background noise there, typing, I think, and then Mars will allow you to ask your question too. I'll point out to the panel and then also the audience after the 2-hour mark, which is more formal, it kind of becomes a free-for-all. And so you kind of got to jump in there and, ask to be part of the uninterrupted portions and stuff. And so we will wrap up this portion soon. We're all passionate here, Sam, myself, Mark. So, but Mars, we're going to make sure you get the question. So anyways, lactase and HIV resistance. HIV resistance is probably one of the better examples of a so-called beneficial mutation. Firstly, I like to point out that you're going to need more than 1 or 2 or even 100 truly beneficial mutations that on the genotypic level is not reductive at all, because I find that 99.9% of the time we're discussing beneficial mutations and defining what a beneficial mutation is. We're defining it based on the phenotypic effects, the physical features of the organism or what's going on, outwardly, basically, like sickle cell anemia. Those with sickle cell anemia, they're actually resistant to malaria. They're not going to get malaria. But what's going on the genotype or under the hood? Typically, it's due to the knocking out of pre-existing systems. And so one example, HIV resistance. That's an interesting one. And so there's a number of people on the planet that are resistant to HIV. And they actually have a mutation. I can hear someone typing. They have a mutation in the gene that makes the CCR5 mutation, okay? And they no longer have it on their T cell. This means the HIV virus, therefore, in those people, cannot bind to that T cell. Because viruses, in order to bind, they basically need a key to bind, to get in, to infect. And so in this case, when you look on the genotype, it's actually the result of a pre-existing protein being knocked out. So a couple things. This mutation doesn't tell us where these genes came from in the first place. Overall, it's reductive and functionally compromising because you're knocking out pre-existing systems. The lactase mutation, same thing. It's a pre-existing regulatory system being damaged. We can get into that, but for sake of time, I won't. Because the point is, you're going to need, hundreds of truly beneficial mutations that are not reductive in any way to counterbalance the damage being done through the influx of so many low-impact mutations pouring in generation after generation. And I'll yield there. Mark, to be fair, we'll hand it to you.
Well, I think
once Mark's done speaking, we'll throw it to Mars.
Yeah, well, I think we should go to Mars and then change to the topic, the evolution fossil topic, because I know Doc's probably
okay.
It was his debate. I feel like I'm sort of hijacking evolution.
And a great debate, by the way, Doc.
Yeah,
it was a good debate.
Yeah.
Oh yeah, definitely.
Thank you. Sorry, I'm not in my depth with all this genetic talk.
No,
we'll have to do a round two because an hour goes by quick.
Mars, you better take your shot, man.
Go ahead, jump
I'm
in,
ready.
Mars.
Please.
Get aggressive.
You guys hear me, right?
Oh yeah.
Yes.
Okay, so yeah, Marshall Apologetics. I just started my YouTube, so atheists and my brothers in Christ can go check that out. So Dr. Dino, on your channel, I believe, on an after show, we had a little quick exchange via text, and you told me we can continue it. You had to go because you were sick that night, if you remember. So you had asked if there's any creationists listening, and you asked a question basically saying, why did you guys think you're a special creation, right? Do you remember that by any chance?
I've asked it a few times. Yeah.
Right. So my response, which I thought was common sense, and I even gave you a biblical backing to show you what God says in his word, was God tells us in Genesis that he gives us dominion over the animals, right? And I was a little bit perplexed because you actually challenged the idea that we even have dominion over other animals. And I'm like, man, we can make an elephant dance in a circus. I think it's pretty obvious. One of your comebacks was that if hypothetically we were in the same kind of biological home, I guess, where whales live under the ocean, that they would have dominion. And there's a lot of hypotheticals there. We actually have whales at SeaWorld right now that we control pretty much what the Bible says we could, So I was, that was the thing through text. It's not always fun to do that through text. So I got about 2 or 3 minutes. If you kind of want to I think that goes against evolution. Anyway, I'll give you a chance to respond.
Right. Sorry. I think at the time I think I had a really sore throat because of the terrible air quality. Thanks, Canada, by the way. Anyway.
I'm in Canada.
Thanks, Donnie. I blame you. Anyway.
I apologize.
I think my main problem was just I don't see why us having quote unquote dominion over animals means that we were specially created. Because in my opinion, humans' dominion over animals is just due to your intelligence. Humans are far more intelligent than anything else, and they know how to exploit the weaknesses of other creatures to make them do their bidding. Does that make sense?
Right, but And I actually took screenshots of that day because I was so perplexed that you challenged it. But that was not what you were actually saying. You were actually challenging the question if we even do have dominion over animals. And we kind of spent 20 minutes going back and forth on that. So I was touching on that, and I was actually showing you how when this came up in the Bible, it's not even New Testament. This is actually the book of Genesis. And the book of Genesis, along with the book of Job, is argued to be the oldest text that was ever written. So we can say it's almost 4,000 years ago. Okay, nowhere near the dominion that we have nowadays, and it still blatantly said that we have dominion, and nowadays we see it more than ever. I'm not saying it's always fair what we do. That's a whole nother topic, but God said that we see it. 4,000 years ago, we were a lot less advanced than we are now. We had no weapons the way we have now, and we still had a dominion even back then, and now we have it even more.
I can agree with that to an extent, but I guess I still just don't see why man's dominion over animals cannot be naturally derived. Does that make sense? Especially since, as you can probably agree, our capacity to control animals has agreed as time has gone on. Like, we're better at controlling dogs and cats today than we were a few centuries ago. We didn't used to be able to tame elephants. We didn't used to be able to make orcas do tricks in an aquarium, right? We've gotten better at it
that's
over
because
time.
we're not that old of a species. As according to your timeline, okay, but according to our timeline, it makes perfect sense.
Yeah.
What you're saying is a long time ago to us is a big difference. And the other thing I will say is, if we're so closely related to these other apes, how come they don't demonstrate even 0.2% of that?
So they do sometimes. So this is a really fascinating conversation, and I know you're short on time. My email's on my channel. If you'd like to actually set up a proper stream to talk about this sometime, I'd love to do that with you. You seem fun to talk to. Would that be okay?
Yeah, I appreciate it. Yeah. That's what I was trying to catch you on today, but yeah, we could talk about that.
Sure. I just know you're short on time, and this is a discussion that should probably have some
4 or
time
5
for.
minutes. I don't know. Okay. Donnie thinks it's a good topic for his show, but I got another 3 or 4 minutes and then I got to go.
Okay.
But yeah, that's the last point I make is it's so if it's simply intelligence, and you guys believe that we're a fingernail away from chimps, then why don't they demonstrate anything even close to some kind of common sense duplicate of what we're talking about here?
So I guess I can go over an example. So chimps, they actually do quite a bit of hunting. They hunt as packs. And something they'll often do is they'll set up traps for other monkeys they hunt. They'll specifically herd them into an ambush using what they know of that monkey's behavior to get them to do what they want. And they do it with other creatures too. That's just one example, but there are others in the primate group, Does that make sense?
Yeah, that doesn't suffice for me, though, because a lot of animals know how to outsmart an animal. That is not having dominion over every other animal.
Well, how would you define dominion?
Dominion, we literally can get any animal we want. We can train them to do things. We can have them as pets. They can do farm work for us. So other than maybe an occasional mutational benefit or a symbiotic relationship, you don't really see any kind of animal truly having dominion over every other animal. Humans have that. Chimps don't emulate that in any regard.
I might agree with not every other animal, but at the same time, humans haven't always had dominion over, by your definition, dominion over every other animal. That's more of a recent thing, and we still can't control some. So if other primates can show a diminished capacity, doesn't that mean that they could hypothetically someday have the dominion that humans have today?
I mean, if we actually did live for another 10 billion years, but I don't believe that we lived for 4 billion years. I believe that all this happened really quickly in the last few thousand years. And even when we didn't have...
That's a different discussion.
Right.
That's fair. That's fair.
Right. But even in your timeline, you don't see anything super long ago that humans had this dominion. It's actually within the last few thousand years, like the Bible said. And yeah, maybe 5,000 years ago, we had less than we have today, but it was still obvious that, you know, I mean, I'm not going to get to dinosaurs and dragons, but we were able to take down big creatures, okay, with like spears,
Sure.
man. You know what I mean? Like, so there was no animal that really had any dominion over us. Yes, we can get killed from time to time, but nobody ever had dominion over us, and we had dominion over them. Like, if you had to round it off, we had the dominion. You know, and again, just because it's not what it is today, doesn't mean that anybody else, especially not any of the primates. I mean, they don't have anything like that, and they should emulate something like that if we are so closely related.
Well, I wouldn't say they should. I'd say they could. Maybe.
Well, chimpanzees,
like
I
just
mean, an
because
octopus could, but
like
you know,
just because your cousin can do super wonderful calculus doesn't mean necessarily that you can as well. You might have the capacity, but maybe you just don't want to.
Can I please add something to that?
Yeah.
The chimpanzees, they hunt in a very organized fashion, very, very sophisticated hunting patterns where some of them act as beaters that push the prey into ones that ambush them. Chimpanzees have very, very sophisticated in their hunting patterns. They've also been known to sharpen things like stones and sort of, at the moment, chimpanzees are kind of going through a stone age. They're making tools, not incredibly sophisticated ones, granted, not incredibly sophisticated, but they're passing them on to their children, like they're giving them the rock that they use to crush things and stuff like that. So when you sort of say we should be seeing something like it, we kind of do. And chimpanzees, they've also been they've been observed placing stones in a certain tree for no other reason that it appears to be some kind of ceremony that they go through. Each chimp, when they reach, this tree, will place a stone in the tree, and we don't know why they're doing it. We can only think, hey, that is some kind of ritualistic behavior that they're doing.
Okay, my response to that is to simply say an animal hunts intelligently does not at all scratch the surface about having dominion over every other animal, or even half the animals, or even a quarter of the animals. I mean, hyenas can hunt very intelligently. Okay, even if, well, I guess there's more scavengers, but the way that they can still manipulate their surroundings in order for them to get the food, even against lions, is pretty intelligent, right? A lot of animals do this.
I mean, to be fair, Mars, you said we should see 0.02% of the dominion humans have in our relatives. Even if it's not as developed, that is a form of dominion by your definition, isn't it?
No, what I'm saying is that they hardly
over another
have
species.
that. They hardly have that, if you can call it that. I don't see them. What I'm saying about dominion is not mean that they can hunt intelligently. Any predator can hunt intelligently. So when I'm saying about 0.2%, I'm talking about using animals, okay, the way we use animals. Hunting is not using animals. Hunting is hunting, okay? I'm talking about having dominion, total control. We can get an animal to guard your house. You can get an animal to dance in the circus, perform at SeaWorld. You can have an animal, you can go to Central Park in New York and you can take a horse ride, right, for entertainment.
Maybe just a hypothetical. What if there were other creatures that could do that, but humans killed them off?
Well, ants do that. Ants herd aphids and milk them. They're basically like cattle for ants.
True.
Ants do that with how many other creatures?
Well, just aphids.
They'll do it with aphids. They'll do it with other creatures.
It's no
like
longer
that.
on the topic. Look, you now just start talking out of your biblical. I don't want to say. You're just talking biblically.
What?
Who said that?
That was
It's
bubblegum. Bubblegum. It's kind
That's
of
no longer
really
on topic.
inflammatory. Well, I think
No,
Mars
it's not.
deserves some time, to be honest.
Yes,
with you.
look.
No, it's actually not simply
He's
biblical.
earned it. He's been here for like an hour.
We're
It's
trying to
not
keep it on
simply.
subject.
It's not simply biblical, because if you listen to what I said in the beginning, okay, I was talking to Dino, with what he said on his after show, where he asked the creationist, "I believe that we are special creatures or special creation." So yes, I use the Bible to back that up, like a Christian should. Okay, but I'm also using common sense.
But
where
this is not about the Bible. This is about evolution.
Hold on, Bubbles.
you're not following, buddy.
Yeah, like everyone has a worldview. Like that's what we're defending: biblical creation.
So, like I said, Mars,
regardless,
this is an interesting topic, though. How about you and I talk about this some other time? I'd be more than happy to.
Okay, but like I said, I just wanted to stand the point. The evolutionists cannot name another animal that emulates the dominion that we have. Yet you guys want to say that we're so close to so many other animals. And I stand with my 0.2%.
Would that be okay?
Huh?
How about I do a bit more
research
research
that
on
if you
that?
want, and you can get back. You can get back at me. I would like to see somebody else who emulates what we do if we're so similar to all these other species. And that's my challenge. That's my challenge to an evolutionist. It should be pretty easy to do.
Well, gentlemen, that was a very interesting conversation. Sam and I, we are trying to wrap it up in and around the 4-hour mark. So maybe we'll move on to Doc. I know you wanted to talk about, at least for a little bit, the human paleoanthropology, and so maybe we can all kind of get in on that a little bit.
Sure, that'd be fun.
But again, we're going to do lots of these open mics, so I think we've already got another one set for next week. And so Mars and Doc, if you guys wanted to make some final points based on what you guys were talking about, and then maybe I'll introduce a topic here on human evolution, and then we'll just kind of run with it.
Abraham,
can I jump in quickly?
Abraham hasn't said anything yet either. And neither has, who's the last person? Justin?
I'd like to have just a short comment.
Sure, go ahead, Abrahams.
I don't mind listening because people who listen, they learn. But people who talk a lot, they just repeat what they already know. So it's no big deal. I'll join in the next time and try to make some comments, if it's okay with you guys.
Thanks, Abraham.
Okay.
Pretty nice advice there, though. Yeah, it's good to listen.
Yeah, I like listening. I'm listening to this kind of debates for the past maybe 15 or 17 years. So I'm still learning, no problem.
Oh, everyone's still learning.
So thank you guys. I'll join in the next time. And
Not me.
That's good. Also, Mars, my email is in the chat. Anytime, man.
Okay.
Justin.
You guys take care.
Take care, Abrahams.
You too, Abraham. Thank you.
Abrahams, thank you for joining. I appreciate it.
Okay,
Justin,
bye-bye.
did you want to say hi before we go on the wild one?
Justin, what's going on, my man?
Nothing much here.
Just living the dream, brother.
Awesome.
So any thoughts, anything you'd like to add to the conversation?
I guess that I never find evolution convincing, but it's always interesting to listen.
Yeah, I think it's important that we're engaging in the same room together, listening to each other's arguments, and kind of hearing each other out. So, Justin, it's good that you're in here listening to even the side that you may or may not disagree with. Mark, looks like you're going to say something. Go ahead.
What would convince you, Justin?
Let's see.
Just tell me you want to evolve for 2 weeks.
I would need a lot of evidence. I mean, it seems like the transition from species to species is just too much to believe that it's just an accident to me. I don't know.
Well, I think. Sorry. Go ahead.
I find it. I'm kind of in a place where I don't really know what I believe, Mark, but I find it very strange to think that everything is just a big accident as a worldview. I find it hard to believe.
You know what they say about people who don't believe in anything? They'll fall for anything.
Well, I don't think
Well-
that's necessarily true. I think that's just
That is absolutely true.
okay. Sure. Okay. Yeah, I don't
mean,
think I'm going to fall for.
If I will fall for anything, that's fine. But I guess what I'm saying is, like, I'd like to have a lot of evidence. Not like it seems like we're arguing about like Tic Tacs when the problems are like global size, right? I mean,
Well,
it's just.
Well,
if I may, Justin, like I've been in your place before. I totally understand it. Best advice I can give: just keep an open mind. Even if you do eventually choose a side, never close off your mind to the possibilities. You could always be
Justin.
wrong.
Hey, Justin, you want me to give you?
I can't be wrong if I don't hold a position, I guess.
Well, when you pick a position, you can always be wrong.
But don't believe in any Nigerian prince scams, because apparently you'll fall for them if you don't believe in anything. I just want to push back on one thing that you said, like
Justin.
It's just 1 second. The whole idea that it's an accident, like sort of the transition from species to species, we don't really in evolution classify it as it's not really an accident. It's a deterministic process, so there's a process churning towards a result, and transition from species to species. Unfortunately, it's seen as like, oh, you know, this ape gave birth to a human, and that isn't what happens. It's such a slow, gradual change. It's like when you're at the gym and you're working out, and then you don't notice the day-to-day changes. There's no difference between you one day and the next. But when you look at a before and after shot, you go, whoa, the change is massive, but you just didn't swap from one to another. So that's the other thing I would sort of say. It's so slow that you wouldn't even notice it generation to generation.
I suppose, again, even if I granted you that, the problem is like you're addressing like a very small portion of what you believe with that. Like, for example, you guys believe that like somehow like cows became whales and things like that? Like, you have to address the whole spectrum. It's just too much to even really.
If I might, I brought up Aaron Ra earlier in my opening. I'd recommend checking out a series he has called The Systematic Classification of Life. It's really good at going step by step at how humans in particular evolved. And he goes through it very slowly and explains it very well.
I got a question.
That might help you to get an idea of at least
the
what
problem
we
is
believe.
even if I grant you all of that, I still don't see how we got
Justin,
to
just say
monkeys and how
you're
we
not
got
willing to be convinced. Justin, just say you're not willing to be
No,
convinced.
it's not that
Just
I'm
stop
not willing
wasting
to
their
be
time.
convinced. It's just I'm not convinced, I
That's
guess.
okay.
I'm not trying to waste their
Justin,
time.
nothing's going to convince you. Just say that.
Well, Bubbles, I don't
Bubbles,
think
I
you should
think you're being a little
I
combative here.
think
Look,
Justin's being really honest and
I have no
upfront.
tolerance for
I
little
mean,
wafflers.
I'm not gonna lie. Like even if I saw it happen with my eyes, I'd find it hard to be convincing. Yeah, I'm very.
Yeah, there you go, folks. Even if he saw it, he would say,
I'm being honest.
One argument that Doc brought up.
What I meant. Let me explain what I meant by that though. I might be convinced in the moment, but I might start questioning what I saw afterwards.
Why?
That's good.
One
That's a good mindset to have, Justin. That's a
See,
good
Justin-
mindset to have. Always
Justin,
re-examine
this is
the
what the lack
evidence
of
that
knowledge
convinces
leads
you
you
of a
to.
position.
Right, and that's about why I hold no position. Is I drove myself absolutely insane over all this stuff. I never really found evolution very convincing, but
Justin, look,
I
if you just wanna-
drove
look.
myself insane over all this
Justin, if you
stuff,
just
and
want to
I
defeat Justin, if you just want to defeat these evolutionists in one question, simply ask him this one question: provide to me one transition between the Dalmatian and the gray wolf one specimen. They will never be able to tell you that. Now, a dino. Do you know the phylogeny challenge from Aaron Ra?
I haven't actually looked through the challenge, but I've heard of it.
Okay. Can you provide to me evolutionary tree for human races? Provide to me the human tree for human races. Anywhere. It
What are
doesn't
you
exist.
defining as
Why is
race?
that?
And Donnie, I know this is a touchy subject, so feel free to cut us off at any point.
Oh my God.
What are you
This-
defining as a race, Bubbles?
It would be haplogroups.
Well, there's one race, the human race. We've discovered that.
No,
through
that's
genomics.
no.
I really wanted to listen. I really wanted to touch on something
speedrun.
that Dok. I really wanted to touch on what Dok brought up in his opening statement to really be on topic as much as possible. And so let's kind of run with this, and let's really focus on human evolution, because Mark asked a good question to Justin.
But this is on human evolution.
Right, yeah.
Provide
But-
to
but-
us the tree.
But
of
we're going
evolution for
back
humans.
to a few of the topics that Dok brought up, rather than having a discussion on whether there's one race.
Well, I don't
within
think we
humans or multiple.
Well, we cannot start this conversation unless Dr. Dino or Mark provides us the tree of evolution for human races.
Okay,
Nobody
Donnie,
in their
can
right
I give a really short summary here?
Sure, go ahead.
Okay, first, really, really important for everyone to get, all human races are equally capable of different things. Just gonna
This
say
has
that.
nothing
up
to
front.
do with racism. This has nothing to do with like the hatred of races or anything like that. This
Second,
is just
Bubbles. So, according to genetic evidence, fossil evidence, etc., it
Yeah, just
seems
show
that
us the
Homo
tree.
sapiens left Africa multiple times.
yeah. What I
There
want
were
from
several
you.
different Bubbles. Can I please talk?
Go ahead.
Humans left Africa multiple times. So all
Okay,
humans
let
are
me stop
from
you there. Let me stop you there.
Multiple times.
Can I ask you something? How do you know that? Like, how could you possibly know anything like that?
They have to say that. They don't have an evolutionary tree for humans. They don't have one. Look it
So-
up. There's not a
Bubbles,
single
you
one.
won't let me say what the evolutionary. You won't let me say what
show
the
me
tree
one single
is.
evolutionary tree for humans.
Hold on. Let's try to let's not
Can I
over talk.
share my
So I
screen?
think yeah, Mark, hold on 1 second.
Sure.
So Justin, I think, asked a fair question to Dok, and I know Mark, you want to answer that.
So-
and then Bubbles, I know you're going to want to respond. So go ahead, Dok, and answer Justin.
My
How do you
point
know
in the question though is this: it's not more to know about that specific question, but like how to examine evidence. And I just noticed people say things all the time, and they trust other people and what other people say, but we really don't know that that's true. I mean, I don't know.
Okay.
That's just my
So,
thoughts.
Justin, I get where you're coming from. Can I give my explanation for Bubbles and then get to you? Would that
yeah,
be okay?
and what one more thing, it's especially with the specifics of things. Like we hear, especially evolutionists, they'll make up these long timelines of things that, frankly, you just don't know. I mean, it just I don't know.
Okay.
Okay.
So this is a map.
Okay, so Mark, please. Humans left
Mark.
Africa multiple times. There were multiple different migrations out of
Yeah,
Africa.
show me the tree. Show me the tree, Mark.
Yes.
Bubbles, I'm going to. They left Africa multiple times and went into different places. Once they went to different places, humans adapted to their local environments. If you've ever heard of Cheddar Man, Cheddar Man was one of the first Homo sapiens to enter England. And he
Yeah,
had
that's a nice
dark
point.
skin, dark hair. I think he had blue eyes.
Who was the first
Nice
people
story.
group?
Now show me
And
the
how
tree
do
for
you know
humans.
that?
Bubblegum, I'm asking a question. Don't interrupt me, please. Who is the people group, the first people group, Dok, that left Africa in your view? Would it be Erectus? Was there an out of Africa with Erectus at first?
First genus Homo. I think it was Erectus, but I could be wrong.
Because
I could be wrong on that.
when Homo sapiens basically left Africa, they met up with Neanderthals. They met up with Denisovans. We already had
Yes.
Homo floresiensis on the island of Flores. So obviously,
yes,
a group must have left before that. So therefore,
Sure.
before right, okay, so before humans, modern Homo sapiens, basically left Africa, another group must have left before. Do you think it was Erectus then?
I think Erectus is the earliest group we have record of, but in this specifically, I'm talking about Homo sapiens sapiens.
Right.
They left
So, but
Africa in several major migrations and to Justin. So we know that there were specific groups that left because human genetic diversity decreases quite a bit as you look at modern populations that are farther away from Africa. So what that basically means is I think it's called the founder effect in genetics. If a portion of a population goes somewhere, they will carry their genetics with them, but they won't be able to capture all of the genetics of the original population. So all the descendants of
Doc,
those pilgrims will have a limited pool of genetics to work with.
Okay, so you're telling me, like, for example, like people who became Caucasian, they can never return to being more like dark-skinned.
No, they could given enough time.
So they can, right?
Skin color is highly variable in humans.
So you're saying it can evolve backwards, right?
Not evolve backwards, but we can evolve to suit new environments.
But that would be a case of it evolving backwards.
Bubbles, there is no evolving backwards.
So
evolution
Back to like
continuously
a
goes
prior
forward.
state. For example, you're saying we came. For example, you're saying we came out of Africa. Okay, let's go with that. And then this population became Caucasian. Can this Caucasian population now revert to being dark skinned like when they were in Africa?
It isn't necessarily a reversion, but yes, they can become darker.
But if you're
Does
So
it
they
ever
can't
does it ever
backwards.
worry you that a lot of this knowledge is just not real?
They're models.
Well, Justin, I'm going to jump in because I really want to utilize the last minutes of this discussion. I want to address some of the points being made. Okay, so Doc, I was asking you a couple questions about the out of Africa events. Okay, there's out of Africa 1, out of Africa 2. There's both in the out of Africa model.
Mhm.
There's the multi-regional hypothesis. So basically, if Erectus left first, how many millions of years ago would you say?
I don't know the time. I specialize in dinosaurs. I specialize in dinosaurs.
No worries. Let's say a couple million years ago, Erectus leaves. So would you then say, since 200,000 years ago, modern humans leave Africa, they meet up with Neanderthals? We literally have Neanderthal genes. We know that modern humans and Neanderthals interbred with each other. So in order for humans to meet up with Neanderthals outside of Africa in Eurasia, Europe and Asia,
yes,
would you argue then that Erectus independently evolved into Heidelbergensis, Denisovans, and Neanderthals?
Okay, so that's a complicated question, especially since it appears that most of the species of genus Homo could interbreed. I believe the current consensus is that Homo erectus became some Homo erectus went into like Asia and Europe, and those local populations, some of them became Neanderthals.
Right. Others
Or
became
could have been Homo
Heidelbergensis.
heidelbergensis. I am not 100% certain on the exact back and forth.
Or maybe a subpopulation of Erectus evolved into Homo heidelbergensis, and then Homo heidelbergensis evolved in Neanderthals. Is that a possibility? That
yes, I'm not 100% certain, but that could be. Though I have heard there are some circles that say Heidelbergensis is also ancestral to Homo sapiens. So it might have been a group of Heidelbergensis that left Africa and became Neanderthals.
Okay, so basically my question is, if Erectus leaves Africa several million years ago, independently evolves in different parts of the globe outside of Africa into Neanderthals, let's say Heidelbergensis, obviously elsewhere, probably into the Hobbit, Naledi, so on and so forth. But only 200,000 years ago, let's say, humans finally leave Africa, meet up with Neanderthals, and they're able to produce fertile offspring with them. That means humans in Africa and Erectus and then Neanderthals, if Erectus eventually evolved into Neanderthals outside of Africa, if they were separated by hundreds of thousands of years, how did they produce fertile offspring? How are they still genetically similar enough to interbreed, but also have children?
Okay, excellent question. So biology is fuzzy. It's very fuzzy in many cases. And there are multiple definitions of like the word species. You've probably heard there are multiple definitions. That's why for my debate tonight with Kent, I proposed a particular definition. Using the definition I proposed, you could say that Homo sapiens and Homo neanderthalensis are the same species. That's basically the biological species concept. If they can make viable fertile offspring, same species.
Right.
But there's another concept, like the morphological species concept, where you group up living things so that you have one group that is all more similar to each other than they are to the next nearest group. By that concept, Homo sapiens and Neanderthalensis are very distinct. Does that make sense?
Well, it does make sense, but I'm not sure if it's a direct answer to my question, because my point is we would have humans existing independently in Africa outside of Eurasia, where apparently, according to your model, Erectus evolves independently into these different groups, Neanderthals being one of them, and Denisovans being another group. Yes. Humans leave about 200,000 years ago. They've been separated for hundreds of thousands of years, maybe for 1 million years or more. And so both groups are independently accumulating their own mutations. Some mutations, depending on how small the population is, are becoming fixed. And so both would be drifting from each other genetically. But yet humans are still able to interbreed with the Neanderthals and produce fertile offspring. How is that possible if they've been separated for as much time as you would have to argue they've been separated for?
Well, because there isn't, like, it's not if you're reproductively isolated for 100,000 years, you cannot interbreed anymore. There's a lot of variables to consider.
Was it only
the human and
100,000
Neanderthal
years?
genome is still very, very similar.
Yeah, it's suggested. We don't know the exact
even
dates.
despite the distance.
Like I think the dates that you're saying, like hundreds of thousands of years, is kind of a bit extreme. From what I've seen, looking through, it's suggesting that it's about 130,000 maybe, is the upper sort of estimate. But we don't know exactly when these happen, so it's very hard to tell the amount of time between them.
Like regardless,
I just find it curious that according to the evolutionary model, you would have this out of Africa event with Erectus a couple million years ago. Mark, maybe you can get the numbers for that. And then eventually Erectus evolves into at least one group, Neanderthals. All this time separated from humans in Africa, yet humans leave Africa and they're able to reproduce with Neanderthals. It seems like a lot
to
of
be fair, humans aren't the only species this happens with. Let me do a quick Google.
Well, have we seen today? I mean, we've got what, 4,000 to 6,000 years of human history. We've only got what, a few hundred years actually observing various species interbreed. And, you know, I know recently in 2017, we saw a new finch species form, a hybrid species, but how long have we been documenting speciation events? Not very long. So if humans and Neanderthals are separated for, let's say, even what Mark said, 130,000 years, why are we to believe that they should have been reproductively compatible?
Well,
so Donnie, sorry, Mark, just really quick. Just because they're separated for a long time doesn't mean they have to be reproductively isolated. Like, I just looked it up. According to what science knows, lions and tigers have been separated genetically for almost 4 million years, but we still have ligers. So humans aren't the only species this can happen to.
Well, that would also tell me that they haven't been separated that long. That's my whole point. It's easier to believe what we would argue, that essentially you have this dispersal event, okay, let's say 4,000 years ago, roughly, and you have Neanderthals going into Eurasia. Well, basically you'd have people leaving the Middle East, and some people groups would become isolated, like the Neanderthals. And so they wouldn't have started off like the Neanderthals, but over time, as they're isolated and existing in these ecoglacial systems, they're also becoming more and more highly inbred. That's why we find these massive stretches of identical letters. These But let me just finish my thought. Let me just finish my thought.
Sure.
And so you find these massive stretches of identical letters. They had high levels. The Neanderthals are the most inbred people group we've ever seen on the planet. And so, yeah, and then eventually humans meet up with Neanderthals. But according to our model, they're not really separated for that long. And so it makes sense. Yes, they interbreed and they can produce children, and we have their genetics today. Eventually that group known as the Neanderthals go extinct. Fits nicely.
So
go ahead.
So Donnie, I understand what you're saying, and I'm not meaning any offense when I say this, but regardless of if one interpretation seems more likely to you, that has no bearing on the evidence. And the evidence we have is that they were separated for that long, but could still interbreed.
But I don't
think what the
think
evidence says.
And this was the point that I wanted to bring up earlier, is I don't believe that there is evidence that they were separated that long, because but Mark, let me finish this and then we'll throw it to you to respond. So I can throw this in here. So we've had a lot of new research done and study into your groups like the Australopithecines, Paranthropus, early humans, right? Homo erectus, which we would basically say are a pathological variation of humans. And so there's been a lot of research lately that has come to the forefront suggesting that all of these groups actually coexisted. Because Doc, in your presentation, you're saying, why do we find Ardipithecus here and then Afarensis here, and then like this nice linear line of morphological change and evolutionary history, essentially. But what we actually see is significant overlap in the fossil record, where we find your Australopithecines, Paranthropus, Homo erectus, which I would say are humans, all coexisting and intermingling.
So great question, and I do have an answer to that, but it is Mark's turn.
Okay.
So I'll give my answer after that, if that's okay.
The Out of Africa 1, unlike Out of Africa 2, which was the modern Homo sapiens or Homo sapiens sapiens, Out of Africa 1 was a diffusion of waves. And so it was waves of population going out. It wasn't just one event. The problem is, Donnie, you're sort of characterizing this as just a bunch of humans went out and they just spread across the earth and made the population. Whereas, like from the map I showed you, which admittedly was Out of Africa 2, it's a lot more complicated than just these people went out and then they created all of these other species. People went out, they came back in, there was waves going out, they interbred, they moved elsewhere. The Neanderthals were probably separated, so there were a lot more interbred, as you said, but the other ones probably had some more groups from Africa join them, changing their genetic diversity and the genetic dynamics that are part of that population. And maybe that wasn't a lot of people, but that's enough to keep them close enough. And Doc's right, like 100,000 years isn't that long as far as speciation is concerned. So I think that it's more than feasible that with waves of population coming out from Africa, that these people still could interbreed. I don't think it's a problem at all.
Okay, instead of pre-supping this out of Africa theory, can you guys provide to us evolutionary tree for human races?
I don't think human races actually exist so much. I would probably refer to.
Well, if you accept haplogroups,
can I
you
answer,
accept
please?
human races.
Can I please answer? I would probably refer to haplogroups rather than any pre-designated races, and I can certainly give you a list of haplogroups.
I'm not going to entertain your liberal vocabulary.
Well, Bubblegum, this right here,
I don't think that's liberal.
Bubblegum,
That's
this
just
is a
scientific.
Well, this is not the tree. This is not the tree.
Sorry, Donnie, go ahead.
Atheists agree. This is your biblical. This is your biblical tree, but atheists
this is
wouldn't agree with this tree.
This is worldwide mitochondrial DNA taken from
I can
the
get to
1,000 Genomes program.
Yeah, I can get
We
to why your tree is wrong, but I'm talking about the atheist tree. I want the
But
atheist.
I'm showing you that humans exist as one race. We have haplogroups here, HVR
No,
haplogroup.
look,
We have the Africa line here as well.
Look, you're too
All in
blind to your
all,
tree.
if you Bubblegum, why are the beginnings of your sentences starting in the middle of mine? I'm not going to take that long to explain this, okay? So we have all different people groups here. We've got African people groups. We've got European people groups. We've got Australian people groups, whatever, Asian people groups. And when you look at the underlying genetics, right, because it's the underlying genetics and DNA diversity worldwide that are manifested in this unrooted phylogenetic tree, they're only separated by a few differences. I mean, on average, it's about 20 to 25 DNA differences separating any two people. That's the average.
Donnie,
I'm almost done. I literally have one more sentence. Or if you look at the African branch, then you're looking at somewhere between 120 and 140. That's trivial. That's nothing.
Donnie,
that
I'm
low
not,
level of genetic diversity suggests that we exist as one race, the human
Donnie,
race.
I'm not looking for your biblical tree. I want the atheists to show me their tree.
Not
So,
a biblical tree.
if I may, Donnie.
Show me your tree.
Sorry, Donnie, if I may, I actually agree
You don't
with
got
you.
one, right? There's not a single tree up.
May I corroborate your point, Donnie? Really quick?
You don't agree with that tree. What would you agree with that tree, dude?
And I think, Donnie, that's just a standard haplogroup tree. It's nothing atheist about it. It's just what the science says about haplogroups.
Okay. Donnie, can you share what I'm...
Wait, hold on. Mark, you accept that tree, Mark?
I'd have to look at it a bit closer, but
so
maybe.
on this slide...
Hold on. Donnie, put that tree back up. Now I want
Mark's right here. That's not like a creation.
Hold on.
Organization who made that. It's just from the 1,000 Genomes Project.
Is that who was that?
Me.
That's Godzilla Freak. Good to see you, brother.
Good
Yeah,
to
it's
see you.
been a while, I guess.
It's like a ninja.
Donnie, do you have that tree?
Okay, let me show the tree real quick, and then Doc, we're going to give you the floor.
Yeah.
I know you have.
I want. Sorry, bro.
Well, I'll say this. So basically, this tree, and you could also look at the Y chromosome tree as well. This is an unrooted phylogenetic tree, and it is representing mitochondrial DNA diversity worldwide. So the evolutionists would agree with, and of course the evolutionists can correct me if I'm wrong, they'll agree with the data. They'll agree with the underlying genetics in terms of genetic diversity, right? They'll agree with the haplogroups. What they'll disagree with is probably the rooting.
Yes.
You know, that they would pick a root somewhere on your L0 branch, basically somewhere in Africa. And so their tree would be a rooted tree where you've got those stair steps, basically the stair step patterns where you have L.
I mean,
and
how can we know if
going
they haven't
into
shown
N
us?
and N. Go ahead. Is that an accurate representation?
Yeah.
I mostly agree. Yeah.
No, but where's the official tree? I mean, this is just conjecture. Until they show us their tree, we can't confirm that.
You can do this tree yourself. You just go into the 1,000 Genomes program. You get enough DNA diversity worldwide, and you can make a tree.
Where is it?
Unrooted.
Where is it?
Where's what?
Well, where's the atheist tree?
Well, I mean, I can.
That is it. They just don't realize it. That's why Mark
said
said
I
it.
can,
But they don't
I can
agree with it.
show you it, but like you said, you didn't want to see it, kind of thing.
What? When did I say that?
Okay. Anyway, real quick here, Donnie, to corroborate what you were sort of saying there. So right here are distributions of pairwise sequence differences. So basically the differences between a human, like 2 human genomes roughly, and say 2 Neanderthals and 2 chimps. And you can see here, we have this nice curve of human variation, but then humans stop around here. Then we start examining Neanderthals, and we see they have a lot more differences, but not as much as chimps. And this is what we would expect to see in our evolutionary worldview, just to use common vernacular, because humans and Neanderthals have been separated for less time than humans and chimps.
So the humans have more fixed locations. Is that what's that showing?
It is showing that these humans share a common ancestor,
No,
basically
I'm
closer
asking you
than
about
the
differences.
Neanderthals.
I'm asking you about the differences. You said that the humans have less differences in their genome.
Yes.
Are you talking about like fixed
Is
locations?
that autosomal? Is that
No, it's like
autosomal
compared to
DNA that
other
we're looking at?
humans.
So I don't know the full context of this.
Then why are you
but,
sharing
like,
it?
if-
'Cause that's what I'm trying to ask you. Why are you sharing it?
If
you're
you
not
pick
able to-
any two random humans and
What's that?
compare their genomes, they're going to fall within this range.
But what do those
Whereas
differences
Neanderthals are going to
represent?
fall within this range.
What do those differences represent? What are those ranges? What is that? Like, what exactly are we looking at?
Well, I think that's why
Yeah,
it's
what
important to
kind
know.
of differences are those?
I want you to
I think
articulate
that's why
what
it's important to
exactly
know
what-
if it's uniparentally inherited DNA like mitochondrial DNA or Y chromosome, or is it autosomal DNA that would experience recombination?
I'm not quite sure on that front. I didn't have time to dig into it too much. If you
I
want, you
think
can
it would
reach out
be
to Chris Thompson
mitochondrial
here.
based on the small numbers, though, right?
Yeah,
'Cause
I'm
autosomal,
thinking
I'd
it's
assume it's
mito.
much more.
I'm thinking
Might
it's
be.
mitochondrial
Not so-
DNA. Because if it is, I've got several papers, and I appreciate those points, Doc. So basically, overall, like if we're just going to generalize it, all humans today, extant humans, are 99.99% the same. When you bring in Neanderthals and roughly and compare them with modern humans, we're about 99.7% the same. But so here's one of my favorite papers here. I highly recommend everybody make time to read it. An abundance of developmental anomalies and abnormalities in Pleistocene people. And so they point out that in the fossil record, when it comes to your hominids, like or hominins like Neanderthals, Erectus, obviously your island populations like Luzonensis and Floresiensis, there's a lot of degeneration going on. There's a lot of homozygosity, morphological degeneration. And so over here, they talk about the Neanderthals. 3 Neanderthal sequences exhibit high levels of homozygosity, implying pervasive inbreeding among their ancestors. So elsewhere, not necessarily in this paper, but I have other papers where they talk about how the inbreeding that they experienced, the massive inbreeding, actually shaped their genetic landscape, telling us that the reason why Neanderthals are slightly different in terms of biodiversity to modern humans is because in a population that has a high mutation rate or is experiencing a lot of inbreeding, if that population is small, what you'll get is the rapid fixation of new mutations. Fixation meaning these mutations that are popping up, they become stuck in place. And so over time, you have your Neanderthals becoming more distinct than humans today. And so that's how, as a creationist, we'd explain why they are slightly different than we are today. And even your own conventional literature is pointing out that, yes, the way that they existed in terms of inbreeding, that shaped their genetic landscape. Go ahead.
So, Donnie, I do agree with you, but this is what we see in basically any small reproductively isolated group, including modern humans before we gain the ability to travel more than 30 miles in our lifetime.
Wait, hold on, Doc. Let's talk about the problem with that. Okay, on your model that you're advocating for, you have a small group that inbred for what, between 80 and 120,000 years. You understand that? So you just acknowledged that inbreeding within a small population accumulates certain mutations and homozygosity.
So just to
How is
clarify,
that a problem, Sam?
To clarify, the diagram
on,
I've
Mark,
researched
hold on.
it. The diagram he showed was mitochondrial DNA. Just to clarify that.
Thank you, Mark.
Yeah, so the mitochondrial DNA, that's the way that you explain that is with when from Luca to explain the human mitochondria you have a small inbreeding population for anywhere between 80 and 100,000 years. But you just conceded that that would be a problem. So how are you going to
No, I
rectify
didn't,
that?
Sam. No, I didn't. I
So
said
it's not a
what
problem?
Donnie is describing
Hold on, be
what
clear.
you would
Is
see
it a
in
problem or
any
not?
small reproductively isolated population. We see
Dino,
this in
Dino,
almost all of
answer
them.
the question. Is it a problem or not? I just want to know.
No,
Is it
it's
a
not.
problem?
This is what we expect to see.
Inbreeding, hold on. Do you agree with that, Mark? Mark, do you agree that that inbreeding for a prolonged period of time within a small population is not a problem?
Depends on
Do
the
you
size
agree
of the
with that, or do you
population.
disagree?
That's not
what he's
No,
saying.
I'm asking you because you hold on, Dino.
You're
calm
misrepresenting what I said.
down. Dino, calm down. I'm not accurately or inaccurately representing. I'm asking a question for clarification. I just want to make sure that you two on the same team agree, because either it is a problem or it's not. Now you're saying it's not a problem, but I'm wondering if Mark would agree with that.
Well, I mean, they didn't exclusively interbreed with themselves. We know that there's Neanderthal DNA in Homo sapiens. So, what's your point?
That didn't answer my question, though.
Well, yeah, but I don't
So
think
my
it's a
question was
problem.
really specific. I'll ask the question again if you want.
Yeah, I think
So on your model, to explain that mitochondrial element, you have a small population of approximately 10,000 inbreeding with each other. It doesn't grow. It stays at about 10,000 to explain that similarity in that mitochondrial element. Now you have that small population inbreeding between 80 and 100,000 years. Is that a problem or not? Is inbreeding a problem or not?
Okay, sorry, Sam. You're asking two different questions there.
There's
What
one
I'm saying,
question. Is it a problem or not?
no, you're not. What I'm saying is that the genetics that Donnie is talking about are what we expect to see in small reproductively isolated populations.
Yes.
That's
You're
what
not
we
answering my
expect.
question, bud.
That is not a problem for the evolutionary hypothesis.
So
It
answer
is
my
a problem for the longevity of the species.
And where are the Neanderthals
So you're
now?
asking two different
You guys are
questions.
just dodging, but that's
Let me
okay.
make a couple points.
It's
So
weird.
firstly,
It's weird. Like what you're asking is weird.
No, it's a
Sam.
really clear question. It was like
So
really
do
clear.
you
I'll
mean
ask
is
it
it
for
a
a
problem
fourth
for
time.
the evolutionary model, or do you mean is it a problem for the individual Neanderthals who are inbreeding?
Is it a problem? Is it a problem for a small population to inbreed?
Is it a problem? What do you
For a
mean the problem to
prolonged
who?
period of time.
A problem for the Neanderthals?
No, I'm just asking you a question, Mark.
Yeah, but
like if we were to
I'm
isolate, hold
clarifying.
on. If we were to, Mark, hold on. If we were to isolate
Yes.
a small people group
Yes.
right now
Mhm.
for anywhere between 80 and 100,000 years,
Yeah.
and they would just inbreed and never really exceed that 10,000 mark, would that be a problem?
Yeah, that would be a problem for them. I don't know why it wouldn't be. But it wouldn't be
So
a
let me make
problem
a
for the
couple points.
evolutionary model. We'd see it exactly what we see in the Neanderthals.
Well, that is your model, though. That's in your model. Like that is
I'll
your model.
explain.
Where are the
I'll
Neanderthals
explain why
now,
I think
Sam?
it's a.
Go ahead.
Where are the
That's your model,
Neanderthals
Mark.
now,
That's
Sam?
what you.
Where are the Neanderthals now?
That's not Mark.
Oh, I'm asking
you're
a question.
confusing two things.
No.
Hold on,
How
hold on,
come you
hold on.
get to
You're
ask
confusing-
questions but I don't? Why? What is this? Where are the Neanderthals
Right.
now?
Let me explain the error in your question.
Well, can you answer my question
You're
first?
You're confusing the belief of your model, ignoring what I'm said. You're saying, well, it's not a problem because it happened. But you just acknowledge that it is a problem. And we're saying that's why it didn't happen, Mark. That's why it didn't
Just because I'm saying it's a problem for the individual Neanderthals doesn't mean I'm saying it's a problem for the model. My point is, then the question that you're
It is a
so
problem for the
studiously
model.
avoiding is that the Neanderthals went extinct. So inbreeding could well have been a problem and contributed towards their extinction, which doesn't in any way be a problem for the evolutionary model at all.
I don't think you understand the problem I just posed.
I don't understand your problem at all. I really don't.
Okay, let me propose something, guys. Let me propose something. So, firstly, the way that the isolation, inbreeding, and just massive levels of homozygosity that are present in Neanderthals. Okay. Again, this paper here is a paper that corroborates our model, where you have, so again, you can check it out, an abundance of developmental anomalies and abnormalities implies the same people. So as Dok has pointed out, when we look at a lot of these hominins, whether it's Hobbit, whether it's Erectus, whether it's Neanderthals, whether it's Naledi, okay, Luzonensis, we see a lot of features that are different, morphological features that are, as evolutionary paleoanthropologists would say, are primitive or pre-human in these creatures. But what we're finding more and more is that your fossil record in terms of these hominids are telling us that they were subject to a lot of inbreeding, a lot of degeneration, a lot of disease, a lot of abnormalities. And so basically, when an evolutionary paleoanthropologist holds up a bone, let's say from Erectus or Hobbit, and says this is transitional or this is basal, what it actually is this atypical feature. What it actually is pathological. It's degenerative. And that's what we're finding out. That's what Eric Trinkos speaks to here. But in terms of the genetic shaping that we see in Neanderthals, this is a counter to what a lot of prominent evolutionists argue is a, I'm almost done, is a challenge to creationists, because they'll say, how do you explain the phylogenetics of Neanderthals and modern humans? Well, again, if we have a lot of mutations coming into the forefront of Neanderthals becoming fixed, and all of your genetic compartments in Neanderthals are shifting and changing, then we would expect those differences basically in biodiversity between humans and modern humans. Last thing, the challenge when it comes to the inbreeding, you guys take as long as you want. I know I'm saying a lot here, but the challenge to the inbreeding has to do with the out of Africa model, right? So today humans exist with extremely low variation. The evolutionary community, they've invoked the out of Africa population bottleneck between 70 and 200,000 years ago, depending what bottleneck you hold to. Okay, so they say that the population was reduced to about 10,000 in Africa, and those 10,000 people existed for 1,000 plus years in a small population in order to reduce levels of genetic diversity. But what we have, therefore, is a small population that is becoming highly inbred. And a lot of recessive mutations would be coming to the forefront. And this would be a near extinction event, this out of Africa model. But we're to believe that apparently all of these people eventually spread out in all parts of the globe, seizing dominion over the planet. And so I think the out of Africa model has a severe inbreeding problem. Go ahead, gentlemen. Take as much time as you need.
Okay. Thank you, Donnie, for making that clear. Just one last thing to what Sam was trying to say. The amount of inbreeding we see in Neanderthals is expected from a small reproductively isolated population. Now, that's not good for the long-term health of the species, but that's what we expect to see in the evolutionary model, because that's just how genetics work. And I don't believe the Homo sapiens population ever got down to as low as 10,000. I'm not sure what the bottleneck is, but I don't think it got quite that low.
Well, that's just an inference.
How low did it get to explain
Can't
the
confirm
low
that.
levels of genetic diversity we see today?
Well, I have
Let me do a quick Google.
Yeah, it was about a few thousand, basically. I've got if I could share a paper on it that basically looks into allele effects and stochasticity might be sufficient to account for Neanderthal extinction. So basically, they're saying that the anatomically modern humans might have contributed to the extinction, but not necessarily engage in competition or out consuming them. So basically, they're saying there is nothing unusual about the persistently small size in the Neanderthal populations. Hominin populations were probably small as well. Basically, they're saying that a level of stochasticity would be reached, and it was a meta-population comprising of subpopulations that had all the stochastic odds against it, and it will only very rarely happen for a significant amount of time. Environmental variability produces low. Basically, it's a cycle. An unfavorable situation will eventually take place, but it's essentially saying there's nothing weird about that population surviving for a long amount of time, even though there is this inbreeding. And I think this did have the numbers.
Hold on.
small population.
If you don't mind.
Yeah, I'm just looking through it.
If you don't mind, what the group that we're talking about that's us, the humans. The humans are the result.
No, we're talking about Neanderthals.
Of that bottleneck. So we're not. No. Well, hold on. No. So look, I explained it really simply because I'm not as technical. And Donnie explained it really specifically. The last common ancestor before human that we allegedly evolved from underwent this bottleneck. And we are the result of that bottleneck.
But
that's the argument. We're not talking about a group that died off. We're talking about us, like you and me on your model. We underwent that bottleneck.
Okay, so if I could
and
just
this
talk
is the
for
result. A sophisticated, intelligent, intellectual people is the result of 10 or 80 to 100,000 years of bottleneck, Mark. That's what you're saying.
Yeah, so Donnie was actually talking about the Neanderthals that came first out of Africa and basically made their population. I mean, I thought we'd been through this already, but I'll go over it again. They were basically isolated from the rest of the Homo species or genus, and they basically had a lot of interbreeding. That was the whole thing that was being made. I don't know why we're sort of going away from Neanderthals,
Mark.
Now,
if I could clarify,
yeah.
Well,
if I could clarify, the Neanderthals went extinct or assimilated with humans.
Yes.
It could have been due to war, conquest, inbreeding, many different hypotheses.
Well, not inbreeding really, but
your modern, what was that, Mark?
Well, it wasn't inbreeding. I mean, if Neanderthals would get assimilated into human lineage,
right,
it wouldn't be into inbreeding.
Right. The inbreeding is proposed as a possible reason why
extinction.
they
Sure. Yeah.
Right. So, anyways, so you have that, but then outside of Africa, before humans even leave, you have this massive population bottleneck, this near extinction event where humans were reduced to somewhere between 2 and 10,000. And they had to exist like that for 1,000 years or more. It's hard to find an exact number. If you could, that'd be awesome. But that would be not a 1 generation bottleneck, not a 2 generation bottleneck, but an extended bottleneck. And so that would be very detrimental to that population because you'd have all of these recessive mutations basically coming to the forefront and resulting in some serious genetic degeneration. But that's the population that's supposed to spread out into all parts of the globe, seizing dominion over the planet. So that's basically where the problem is. Go ahead.
Sorry. Sorry, can I say 2 quick things? First, I think Beamsy has a question. Second, can we please get off of genetics? Can we talk about fossils and rocks? It's my thing.
You know, it's funny because we're on.
We talk about Gobekli Tepe. That's what
I did bring us to the fossils because I brought up that article that talks about the coexistence of Paranthropus, Australopithecines, and Erectus, but it always goes back to genetics, and I'll tell you why. I think on both sides, genetics is the best way to answer the question of ancestry, and I think that's why the evolutionists would argue that the best arguments for evolution are in genetics, probably, and then as a creationist, I'd argue the same. But
there's a reason.
I will agree for direct ancestry. I wasn't advocating for direct 1-to-1 ancestry in my presentation.
Right, you're looking at the fossil record, and that's why I brought. So I know, Doc, you wanted to respond to the article that talks about how we have overlap with Australopithecus, Paranthropus, and Erectus. So rather than this nice, neat, linear line, basically from Ardipithecus to Afarensis to Habilis to Erectus to modern Homo sapiens, I think we actually see a lot of overlap, coexistence, intermingling, interbreeding. Go ahead.
So there is a lot of overlap, and like I said, biology is messy. And in paleontology, we don't try to establish direct ancestry. It's very hard for us to do that. Instead, what we do is
is that a confirmation there's no tree, right?
Is we look at the fossils we have as representatives of the population at a given time. And what I was saying with my presentation is through geologic time, we have shifts in the populations of apes we see in East Africa. They go from, say, Ardipithecus to more genus Homo. Now, it's not a perfect gradual transition. There's overlap, there's species. Some species aren't directly ancestral to another. That's just
None of
how
them
it's going to
are.
be.
Wait, none of them are.
Wait, question. What exactly
Dino,
is
none
the
of them are.
utility? What is the utility in painting a linear sort of picture of
They
ancestry?
don't have a linear picture.
So,
But is that even inherently
So,
is that
so the utility is usually just for the sake of simplicity.
No.
Oh, so there's no, so it's just constructed out of nothing. It's not even.
Yes.
Well, that's not what I said.
I can answer
It is
that.
inferential.
I can answer
It is
that.
true.
Simplify the model
Bingo.
to make it easy for people to understand.
No, it's not.
So-
It's because you
But what
don't
if
have
it's
any
not
transitionals.
true?
Stop lying
Can
to
I
me,
say
Dino.
something?
If it's not
Can I say
true,
something, please? So
then oversimplifying it doesn't count.
No, well, when we do a lot of these complex systems, like for instance, if you're working with
It's not
electronics,
complex.
you probably don't want to draw your diagrams in terms of the actual electronics, like all of the electronics, the resistors and capacitors. And excuse me, I could be sure that I was talking right now. I must be mistaken. or
Bubblegum,
something.
just let Mark finish, and then you can.
Like
go.
you could draw it in terms of resistors and capacitors and all that kind of thing, but the simpler way and easier way to explain how a circuit works is you draw it in terms of logic gates. Logic gates don't actually exist. They're not a thing. They're just basically made up of electronic circuits that we simplify down to show how something works. And we're doing the same thing with this. We're just simplifying it to show how it works.
Yep.
Okay, time for me to
Like,
respond.
maybe an analogy
wait,
Mark was just saying.
Wait,
Okay, let me finish.
Listen,
My turn.
Mark could explain all the circuitry behind an on switch.
Yes.
And then I can just say, I push the switch and it goes on.
No.
Okay,
What I'm
what's real?
saying
The
is
transitions are
still
real.
true. It's just a simplified version of the truth.
Wait a second.
Because not everyone understands circuitry diagrams.
Wait, let me respond to this. I
Wait,
was the first
Sunflower
one to
first.
bring it up. No. I was the first one to bring it up, please.
Okay, go ahead.
So Mark and Dino, what you just said amounts to, okay, once you have a complete picture, as in there's no mysteries from start to finish, then yes, your logic gate can simplify it. That's not what's happening with the evolutionary picture, right? The evolutionary picture is actually you're basically proposing a explanation in which one does not already, you don't have the full picture, and then you're just simplifying it. You're basically saying, well, let's fill in the gaps because there's no better explanation. That's different. That's different from having a complete understanding of a circuit and then saying, well, I can simplify this circuit by using logic gates.
Okay.
I
So
don't
that
think
was
that's
an analogy. It's not going to be perfect.
But
There
it's
are
not
going to be
analogous.
gaps in the
It's
fossil
bad
record.
Analogy,
Wait. I
It
understand.
wasn't an analogy.
No, Dino. Look, I'm being fair. I'm a very fair person. It was an attempt at an analogy, but it was not analogous. So,
Well, it's analogous to simplifying things so people can
No, it's
understand.
not. You don't. Okay, look.
You
the
don't have a full
transistors actually
picture
exist
of
on the
the
motherboard.
start
Your
to finish
transitionals do not exist.
evolution.
You're just inferring
I'm
your
sorry you
transition.
don't see them, Bubblegum, but they do exist.
Oh,
Can-
okay, go ahead.
The point-
Go
you
ahead,
don't have
Dino.
a-
someone more
Provide to me the
substantive.
specimen. Provide to me a transitional specimen between the gray wolf and the Dalmatia.
I don't care about the gray wolf and the
You said they
Dalmatian.
existed.
Bubbles,
You
get
said
a new
they
argument.
existed. Provide to me the transitional then. Admit it. You're inferring your transitionals.
No, I just don't care enough to look
you
into
don't
it to refute you.
Bubblegum
I
can't
don't
do
care.
it.
Bubbles.
Listen,
I don't care.
You can't do it.
Listen, you still are inferring though a whole lot. Come on. You're not
Yes,
gonna
I
sit
admit
here and
there
tell
is
me that-
inference, but not every
lot of it.
inference
Well,
is
the
just a
whole thing.
wild guess.
Okay,
In
but
science, we don't
Dino-
just make wild guesses, we
Dino.
make inferences based on the evidence we have.
Dino,
You're
when you
making
have
up your
when you have a
evidence, dude.
complete
You're
knowledge
admitting
of a
you're
circuit.
making up your evidence.
No, Bubbles, you're
Wait,
saying we make up our evidence.
Hold on.
That's what an inference is.
Bubblegum, hold
That's not what an inference is.
dude, please hold on. Let me just
All right, we're gonna hold on. Just a point
Dino,
of moderation. Hold
Dino,
on. You're gonna go next, Sunflower. You're gonna go next. But let's
let
try
me
to
just ask you a question. Let me just ask
Yeah,
a question.
no, I am. Hold. I'm just gonna ask that everyone not overtalk each other. We were
Okay.
having a pretty good conversation, and everything was all right.
Fair.
I
Actually, Sam,
apologize.
gentlemen,
I apologize.
It sounds like everybody's enjoying the discussion. We're at the 4.5 hour mark. We were going to wrap it up around here, but I can allow this to continue as long as we keep it professional.
Yeah.
I'm going to be stepping away for probably about 30 minutes. I got some food ready for me. I'm going to relax. If people still want to continue this discussion, do people still want to hang around? And because it sounds like everybody's having fun.
Yeah,
and
I have a
therefore-
question for Dino. I just want to.
Well, Sunflower, before you do, I want to hear from everybody. Does everybody want me to continue this show, or should we?
We always get
start
to have fun when
mean-
Bubblegum's around because
Yeah,
he has like the
I
third
got lunch
position,
to
you know?
go, but I can hang around if you want. I think this has been fun.
Okay. Well,
I mean, I have an
appreciate that,
after
Mark.
show set up on my channel
Oh,
if you want to
what
cut the
time's
stream,
that,
Donnie.
Doc?
Like we can transition over to my after show.
Sure.
Okay, let me therefore finish what I was saying earlier, and then we'll slowly start to wind it down. Sam will probably wrap it up completely, maybe another 10, 15 minutes more. But to finish what I was saying, and then Sunflower, we're going to hand it to you. I know you had a question, but we've kind of diverted from what I was bringing up to Doc. And so my point, like, for example, here's Donald Johansson, right? He talks about how his collection that he originally unearthed suggests that Homo and Australopithecus coexisted as early as 3 million years ago. So I oftentimes explain that when you have two different models, the creation model and the evolutionary model, or two different worldviews, we are interpreting the evidence related to our models or worldviews. Okay. But there's a lot of overlap within those models. So if I were to say, Doc or Mark, creation's true or separate ancestry is true because the sky is blue, you'd say, well, no, because the evolutionary model can also explain why the sky is blue. And so I would argue there's a lot of overlap and a lot of lines of evidence that both models can explain. It's not discriminatory. And when it comes to the hominin fossil record, to bring my thoughts to a major point here, Doc, since we see overlap, okay, you interpret that one way as linear evolution from Ardipithecus to Australopithecus to Homo and to eventually modern humans. But for us, we would argue again, you have a dispersal event at the Tower of Babel where you have Neanderthals going one way, or a group that devolves into Neanderthals going one way, Erectus, Naledi, Floresiensis, and then modern humans which extend to today. We also have the Australopithecines that would exist in Africa. And so we see all of these groups coexisting, and this being consistent with the creation model. And so we interpret it that way. It's consistent. You interpret it a different way. You argue it's consistent. And so, Doc, do you understand my point, and do you understand where I'm coming from on this?
So I think I understand, Donnie, but just really important. I'm not saying it's a linear path from Ardipithecus to Homo sapiens.
Right.
It is a wild, confusing mess. And we're just doing our best to make sense of it. But what we do have is these bones are in a rock layer that is 6 million years old. We have Homo sapiens that is in a rock layer that is 50,000 years old.
Well, that's
And
because
while
some
there might
groups
be some overlap. While there might be some overlap in the middle, the beginning and end are separate. And as we go forward through time, there is a progression from one to the other.
See, and that's where I'd argue it does from your model, but I'd argue that's not what we see. And so I've got a lot of papers and excerpts and diagrams here that show, yeah, it's a bushy mess. There's a lot of overlap. There's a lot of intermingling. And I'd like to go here. So, for example, even with Sediba, they're talking about how basically, if you see my screen, new studies shake up human family tree, where you've basically got a lot of dead ends, where you've got a branch that doesn't really go anywhere. It's just, it goes off to the side. It's an extinct group. So yes, I would agree with you that we have modern humans today in the earliest rocks. We have a lot of extinct groups like Erectus, like Neanderthals, like Denisovans, which we only have a few bones for anyways. But that's not evidence for any forward evolution. That's just evidence of coexistence and intermingling of different groups. Some groups have made it to today. Other groups have experienced dead ends. They went extinct. They didn't make it.
But Donnie, there is no overlap between Ardipithecus and Homo erectus. Homo erectus does coexist with some species of Australopithecus, but it doesn't with all of them. Right?
That I think is debatable, because I think we have direct evidence for Australopithecus and Homo existed, specifically Homo erectus.
So
But with
Australopithecus,
but with Ardipithecus, you know, we might not have direct evidence of the bones intermingled. I mean, we actually have, for example, Australopithecus sediba, Ella Bean and Yoel Rack here. Notice human missing link fossils may be jumble of species. They conclude that Australopithecus sediba is not taxonomically legit. It's the co-mixing of erectus bones and Australopithecus bones. So we know there's overlap there. But with Ardipithecus, that could be the case because we understand all. Okay, go ahead. I'm saying a lot there. Go ahead.
Sorry. So I have heard there are refutations to this study first. Second, when I say Australopithecus, Australopithecus is made up of at least 5 different species, not all of them contemporaneous with each other. Homo is made up of at least 5 species, not all of them contemporaneous with one another. Some Australopithecus are contemporaneous with some Homo, but there are multiple species within those genera that do not intermix, and there can always be offshoots within a genus. Like Australopithecus sediba might not be ancestral to Homo sapiens, but Australopithecus afarensis might have been. Does that make sense?
That's going to be, well, again, it does from your model, but we've had lots of discussion within the paleoanthropological community with Johansson, with the Leakeys, with Lee Berger, with many, Chris Stringer, whatever. A lot of discussion on which of these bones belong to which species. Even Lee Berger, he made a video recently on species, and he points out that afarensis, even he would argue that afarensis is chimeric. It's the accidental mixture of different species. Okay, so it's not just one.
Specimen was he talking
wait,
about?
I just talk, please.
Sorry.
Okay. And I know it's an exciting topic, but I got to get these thoughts out. Okay. So it depends on how you interpret a lot of the footprints, a lot of the stone tools, a lot of the bones, right? There's a knee bone, I believe it is, attributed to afarensis that a lot in the paleoanthropological community have said this is a knee bone right here. And so is it like an erectus knee bone? If so, then basically Lucy and erectus coexisted. Or for example, the Laetoli footprint. If you look to these as being maybe an erectus footprint, well, now you have to conclude that, yeah, Homo and afarensis coexisted. So it's going to come down to how do you interpret a lot of the external evidence. Go ahead.
Okay, so Donnie, I'd just like to make it clear for the audience, we have hundreds of individuals for Australopithecus afarensis and Australopithecus africanus. Like, we have hundreds of individuals. We know what an Australopithecus afarensis looks like. We know from head to toe, basically. And they are not a member of genus Homo. There are many differences.
I never said Australopithecus was a member of genus Homo.
You said
I'm saying the Australopithecines and the Homo genus coexisted. But I am arguing
you did say they were the same thing earlier, just due to genetic deformity, or that they might be.
Not the Australopithecines. I was saying
no, Doc, you're getting it mixed up.
I was saying erectus, Naledi, the Hobbit, the hominins like in the Homo genus. Those are the result of degeneration and reductive evolution. But your true Australopithecines, and I'm not talking about the human bones associated with the Australopithecines like Yoel Rack and Ella Bean would point to with Sediba, but the true ape bones, which you would say is non-human ape, take those out, then you've got a very ape-like creature. Okay,
but
so those
Donnie,
exist, but they're not human.
Donnie, we have other Australopithecus. Like the paper you're talking about is about, I think, 2 individuals.
Sediba.
We have hundreds, and not Australopithecus sediba. We have hundreds of Australopithecus, the genus of various species.
Yeah, I've studied it. Yeah, you got Anamensis, Africanus. You've got
and
Prometheus. Yeah,
like is Littlefoot a mixture of Homo and Australopithecus bones?
Which one?
Littlefoot.
Littlefoot is.
I don't know the species or the
that's a tough
specific name off the top of my head.
Yeah, that's a great question. Australopithecus, Prometheus, I believe. I think Mark would probably be able to clarify that. So Littlefoot is a good one. I haven't made a dogmatic interpretation of that yet, because even the conventional community admits that there's not been a ton unveiled yet in terms of the details of Littlefoot. You know, oftentimes it takes a while before we have detailed technical work where we can look at each bone and look at all the morphology. So unfortunately, it's taking a long. I mean, they first discovered Littlefoot when, like 1996 or 7 or something like that. Doc.
Sorry, I was distracted. What'd you say? We've been going for 4.5 hours. My brain is
we've been going for 5 hours. We're getting tired.
Well, can I ask a question?
So I'm not sure about Littlefoot yet. I'm
Okay.
still waiting for some more.
Can I ask a question that's lull, but
technical work done on it.
always fascinated me? How, if Homo sapiens and Australopithecines are in the same era, and they're both just destroyed by the flood, right? Except for Noah and stuff, right? Is that what happened?
Oh, I thought you're
okay.
Can you reiterate the last part?
Australopithecines and humans lived at about the same time, right? And did they all get destroyed in the flood? Why did the Australopithecines die out?
That's a good question. No, I believe everything we see in terms of your hominin and hominid fossil record is post-flood.
Okay.
And so you'd have, yeah.
Okay.
So I think you do find some, like, I want to say this because it's also in response to something Doc said. I think you find some of these creatures like Ardipithecus ramidus or some of your Australopithecine types. I think you find them earlier in the rock strata than humans because they spread out first. Because we understand from the Bible that humans didn't spread out. Remember, they stayed isolated at Babel, and then eventually God had to confuse the languages. But prior to that, I'd say for about 500 years, a lot of your other creatures, like your ape types, they actually spread out to different parts of the globe, and so they were buried first because they spread out first.
But you said a lot of different other things spread out. So why is it that nowhere on Earth there is a modern human below a Australopithecine, and the Neanderthals are always sort of below, above the Australopithecines as well. So why is that we never find Neanderthals at the top, for instance, like you were saying, they spread out as well? Why are they always or never at the bottom? What if they spread out with them? Why do we never see that?
Good question. So I think we see a lot of overlap, okay, where they are coexisting, especially with Neanderthals, mostly all of your hominin types. Bring in Naledi, bring in Floresiensis, Erectus. They're coexisting. They're in the same rock stratas. You even have some Australopithecines and Paranthropus, okay, in the same rock strata coexisting. There might be a few variations of Ardipithecus and Afarensis that are lower than, let's say, your Homo types, but I would argue that's because those types spread out first, got buried first, went extinct. Like your Neanderthals are found earlier than modern Homo sapiens because Neanderthals went extinct.
Well, but Neanderthals
Erectus went extinct.
Neanderthals
Modern
don't coexist with Australopithecines.
Well, we find
Erectus. Well, Australopithecines they did overlap some of the earlier, by our model, earlier Homo groups, but not Neanderthals. Erectus. So if they spread out Neanderthals and Australopithecines and all these other sort of species of human-like things, why do we all see the Australopithecines specifically always underneath?
I don't think it's, if you mean by always underneath, as in we find some Australopithecus species before we find Neanderthals,
in the fossil,
and before we find
the age of the rocks.
Okay. Yeah. Well, for the same explanation that I gave, I think after the flood, God commanded everybody to basically spread out. Humans didn't, but other creatures other than humans, or the apes, like you would say, non-human apes, okay, they spread out. They didn't just stay isolated in one spot and start building the Tower of Babel. And so a lot of them would have just become extinct and been buried. And so they're buried first. A lot might have survived for a bit until humans spread out. So I think it's because they spread out earlier. And so they're found earlier in the rocks. But I would still argue that we find a lot of overlap. But I do agree with you that we find some species earlier than we would find Neanderthals and humans. But Erectus, for the most part, I would argue, which I would say is human, we find intermingled with almost all of your hominins, including Australopithecus and Paranthropus. Go ahead.
Yeah, I just find it hard to believe that if sort of all of these Australopithecines spread out and the sort of the different ones spread out, that it would be neatly, well, not neatly, but it's more ordered than just what you would expect if just a whole bunch of human-like organisms spread out, and you know the age of the rocks is layered, that Neanderthals never overlap with any Australopithecines. Homo erectus does, Homo nalensii does, Homo heidelbergensis doesn't. So you've got to somehow explain why you would have to have the most organized migrations outwards in order to find themselves buried at these intervals. And I don't see that as very, very good explanation.
So let me give one response with the visual, and then I want to give, out of fairness and respect and just appreciation for everybody that joined the show, including the skeptics, Mark and Dok. I'll give you guys the quick last word. Since we are at the 5-hour mark, I think Sam and I are going to tap out. We're getting pretty tired.
Yeah,
I got some food waiting for me. So, and then I know Dok has an after show. So let me say this real quick. If I were to visualize it, okay, in the separate ancestry model, we basically have modern Homo sapiens, which we would say are Adam and Eve for the most part, with some difference, of course. They go along here. They experience a bottleneck at the flood. Okay. They continue on to, let's say, the Tower of Babel, and that's where you get the dispersal. So you get all these different side branches. You get Hobbit, you get Naledi, Denisovans, Neanderthals, Erectus. I would argue all of these hominins have evidence for pathology. They have evidence for genetic degeneration, for disease, which explains a lot of their atypical features, the reduced brain size, the small skull, reduced chin, so on and so forth. So these groups, as you can see, they become extinct. They don't continue on to today. And so I would expect, therefore, to find overlap, because we do find overlap. Again, we find Erectus with a lot of your other non-humans, okay, like your Australopithecines. Not all, but most, I would say. And so we'd find these buried earlier with some overlap, including overlap with your non-human apes, but humans living on to today, modern humans, we didn't go extinct. And so we live to today. And so these would be buried first, essentially, with, again, some, I'm just repeating myself, but hopefully this visual helps, even if you may disagree with it.
Yeah.
Go ahead, have the last
yeah,
word.
it doesn't sort of address it, because it's sort of the Naledi and Erectus, sure, but not Neanderthal. So the way that looks is that you'd find sort of robustus, Australopithecine robustus next to Neanderthal, and that is just not what we see in reality. So I don't think that works for that reason, because we don't find the overlap between the, like, Heidelbergensis, that's a later Homo sort of species. We don't see that overlapping with the Australopithecines at all. So that's why I think that diagram is very inaccurate, because you sort of pointed out the ones that do overlap while sort of ignoring the ones that definitely don't.
Mark, I appreciate the final words. I'm going to give you the final words.
Thank you.
One of these days, you and I are going to. I think this has been great. This has been a lot of fun. I'm glad we made it to the 5-hour mark. So this has been an epic. Our last evolution open mic went about 4.5 hours, so we topped it. We'll have to do another one soon. Mark, you and I will have to just have a one-on-one one of these days. I'm sure people would love to see that showdown. So, okay, to all the skeptics and non-skeptics, I mean it when I say I appreciate the engagement. I love having a packed house the whole time. It was great to see how many people were in the backstage and just excited to discuss the topic of origins. I mean, it's fascinating. We can talk about it all day. So, Doc, I got to say, excellent debate with Kent. That was a lot of fun. The hour flew by. We'll have to do another one soon. Let's get some final words from you, Doc.
Actually, before I do that, I know Beamsy has had a question for a while. Could he ask it quick?
It wasn't really a question. It was just a critique on what Sam was using as evidence.
Okay. In that case, fun first debate. I wish Kent had interacted more. When I asked him what I'd been arguing, he didn't have an answer. It's kind of disappointing. If anyone else wants to debate me on the age of the Earth or some lineage's evolution, not counting bubblegum, I'd be happy to debate. Pick humans, whales, birds. Birds are my favorite. I'm a dinosaur specialist. So if anyone wants to do that, I'd love to.
I would debate you on dinosaurs.
Anyway, thank you for having me, Donnie. This was fun.
Okay, Doc.
I
thank
look
you.
forward to drinking heavily after this is over.
We'll do more of these. Doc, maybe you and I will go at it too. Okay, so anybody who wants to continue the conversation, Sunflower, I feel horrible. I know you had a question. Continue it over on Dr. Deinos after show. Okay, so Doc, you're still having the after show, right?
Yeah, would you mind posting the link in chat so people can go?
Okay, well, people head on over there, see science. I feel like you're just itching to get in there. So everybody go over to Doc's channel. He's having an after show.
I don't know why he doesn't want to make bubblegum though.
No worries, Donnie. Always appreciate your lives, man. You are a very, very solid moderator and just facilitator. Appreciate it, man. Really do.
I appreciate that, brother. You're always welcome here. Again, we're going to do another one of these soon. So everybody feel free to join. Actually, next week, we're having Paul Price open mic. So I'm really hoping to see some of you guys. Mark, you, hoping to see you, and, whoever. So, okay, guys. Blessings all to the audience. I appreciate all the super chats, the support, and Standing for Truth is out. We'll see you later.
I want to give a big thank you to every single channel member who does so much to help me and the community have a fantastic time and keep producing more content. Thank you so much, everybody.